Have you ever found yourself lying awake in the deepest hours of the night, when the world around you has fallen into a heavy silence, and the distractions of the day have faded into the shadows, and felt a sudden, overwhelming sense of vertigo? I do not mean a physical dizziness, but a vertigo of the soul, a sudden realization of just how strange it is that you exist at all. It is a feeling that often comes when we look up at the stars, those ancient fires burning in the velvet darkness. But it can find us anywhere. It can find us in the quiet of a morning room, in the complex geometry of a flower, or in the steady rhythm of our own heartbeat. It is the sudden, terrifying, and beautiful suspicion that there is something behind the curtain of reality, a logic so vast, a precision so exacting, and a truth so profound that our human minds are barely equipped to touch the edges of it. We often use the word God to describe this feeling, to put a name to the mystery that breathes behind the equations of physics and the swirling galaxies. But tonight, I want to invite you on a journey that goes beyond the simple labels we use. I want to take you into the heart of the scientific understanding of our origins, into the terrifying precision of the laws that govern the cosmos, and explore a truth that is perhaps even more awe-inspiring than any myth we have ever told. This is not a story about a deity sitting on a cloud. This is a story about the mathematics of existence, the staggering improbability of life, and the silent, invisible order that holds the universe together. It is a story about how you, in your fragility and your consciousness, are connected to the very moment of creation, and how the forces that shaped the first stars are the same forces that are, right now, holding your atoms together. To understand the terrifying truth about the nature of this order, we must first cast our minds back, far back, beyond the history of humanity, beyond the formation of the earth, beyond even the birth of the sun. We must travel back 13.8 billion years to a moment of singularity. Before this moment, there was no time, there was no space, there was no darkness, for there was no place for darkness to exist. There was only a potential, a seed of infinite density and infinite temperature, containing within it everything that ever was and everything that ever will be. And then, in a fraction of a second so small that there are no words in our language to properly describe it, the universe began. It did not explode into an empty room, for there was no room. It created the room as it expanded. Space itself unfolded like a blossoming flower, stretching out and faster than the speed of light, carrying with it the energy that would eventually cool and condense into the matter that makes up your body. But here is where the story becomes truly strange. Here is where the first hint of that terrifying precision begins to appear. Scientists who study the early universe, the cosmologists who trace the echoes of that primordial fire, have discovered something that keeps them awake at night. They have discovered that the universe was born with a specific set of numbers, a set of fundamental constants that determine how gravity works, how atoms interact, and how energy flows. These numbers are not random. They are tuned with a precision that is almost impossible to comprehend. Imagine for a moment that you are standing in a vast control room, a room that stretches out to infinity in every direction. In front of you is a console with hundreds of dials and sliders. Each of these dials controls a fundamental aspect of the universe. One dial controls the strength of gravity, another controls the weight of an electron, another controls the force that holds the nucleus of an atom together. Now, imagine that these dials are set to very specific positions. If you were to reach out and turn the dial for gravity, just a fraction of an inch to the right, making gravity slightly stronger, the universe would have collapsed back in on itself millions of years ago. It would have ended in a fiery crunch long before the first star had time to ignite. There would be no galaxies, no planets, and certainly no you. Now, imagine you turn that same dial a fraction of an inch to the left, making gravity slightly weaker. The matter from the Big Bang would have flown apart so fast that it never would have clumped together. No stars would have formed. No galaxies would have spun into existence. The universe would be a cold, dark, and empty void, filled only with a thin soup of drifting particles. The setting for gravity had to be precise to within 1 part in a million billion billion. It is a level of accuracy that is equivalent to firing a bullet from one side of the observable universe and hitting a target the size of a single coin on the other side. And that is just one dial. There are dozens of them. Consider the force that governs the interactions between protons and neutrons, the strong nuclear force. If this force were just 2% stronger, hydrogen would have fused into helium so quickly in the early universe that there would be no hydrogen left to form water or to fuel long-lived stars like our sun. The universe would have burned itself out in a flash of nuclear fire. If it were 2% weaker, the nuclei of atoms would not hold together. The complex chemistry that makes life possible, the carbon that forms the backbone of your DNA, the oxygen you are breathing right now, none of it could exist. The universe would be a sterile wasteland of simple protons. This is what physicists call the fine-tuning problem. It is the realization that the universe seems to be balancing on the edge of a knife. The conditions required for life, for complexity, for consciousness, are so incredibly rare, so vanishingly unlikely, that their existence feels like a miracle. When we look at these numbers, when we see how the expansion rate of the universe was calibrated to such an exquisite degree, we are forced to confront a question that shakes the foundations of our understanding. Is this just a coincidence? Are we simply the winners of a cosmic lottery, with odds so low that they are effectively zero? Or is there something else at work? Is there a deep underlying structure, a logic woven into the fabric of reality that inevitably leads to the emergence of complexity? Some great scientific minds have looked at this data and felt a shiver of recognition. The astronomer Fred Hoyle, who coined the term Big Bang, was an atheist, but when he discovered the precise resonances in the carbon atom that allow stars to produce the elements of life, he was shaken. He later wrote that a common-sense interpretation of the fact suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking of in nature. He felt that the universe looked like a put-up job. Einstein, too, felt this presence. He did not believe in a personal God who answers prayers or punishes sins. He believed in the God of Spinoza, a God who reveals himself in the lawful harmony of the world, not in a God who concerns himself with the fate and the doings of mankind. For Einstein, the divine was the order itself. It was the fact that the universe is comprehensible. It was the fact that we can write down a few simple equations on a piece of paper and describe the curvature of space-time or the energy of a photon. The most incomprehensible thing about the universe, he famously said, is that it is comprehensible. Why should the universe follow laws? Why should chaos give rise to order? Why should a massive explosion billions of years ago result in a world of such delicate beauty, where light dances on water and minds contemplate their own existence? This is the terrifying truth. We are not separate from the universe. We are not observers looking in from the outside. We are the universe. We are the result of those dials being set exactly where they are. The iron in your blood was forged in the hearts of giant stars that lived and died billions of years ago. The calcium in your bones was created in the explosions of supernovas. The hydrogen in the water that makes up most of your body was born in the first few minutes of the Big Bang. You are a child of the cosmos, constructed from the debris of ancient stellar catastrophes, held together by laws that were written into the fabric of space and time at the very moment of creation. And this connection implies something profound. If the universe is fine-tuned for life, if the laws of physics seem designed to produce complexity, then perhaps consciousness is not an accident. Perhaps we are not just a random byproduct of blind evolution. Perhaps we are an integral part of the cosmic story. The universe has spent 13.8 billion years evolving, cooling, condensing, and organizing itself, becoming more and more complex until finally it produced a creature that could open its eyes, look up at the stars, and ask, "What am I?" In a very real sense, you are the universe waking up. You are the cosmos becoming conscious of itself. But let us go deeper into this mystery. Let us talk about the vacuum of space. We tend to think of space as empty, as a nothingness that sits between the stars. But quantum physics tells us a different story. It tells us that empty space is not empty at all. It is seething with energy. It is a frothing sea of virtual particles popping in and out of existence, appearing and disappearing in timelines so short we cannot measure them. This energy of the vacuum, this dark energy, is what is pushing the universe apart, accelerating the expansion of the cosmos. And here again, we find that terrifying precision. The value of this dark energy is incredibly small, but it is not zero. If it were slightly larger, the universe would have been torn apart before galaxies could form. The stars would have been ripped away from each other, isolated in lonely patches of expanding darkness. If it were slightly smaller, the universe would have collapsed back on itself. The value of the cosmological constant, this energy of empty space, is tuned to 120 decimal places. To write out that number, you would need to write a zero, a decimal point, and then 119 zeros before you reach the first non-zero digit. That is the precision required for you to be sitting here today. When we confront these numbers, we are left with a sense of vertigo. It is the vertigo of standing on the edge of a cliff and looking down into an abyss of improbability. How can we explain this? Some scientists propose that there are infinite universes, a multiverse of endless bubbles, each with its own random set of laws. In most of these universes, the dials are set wrong. Gravity is too strong, and the universe lasts for a millisecond. Or the nuclear force is too weak, and no atoms ever form. These universes are dark, dead, and barren. But in a few rare bubbles, by sheer chance, the numbers align. The dials settle into the Goldilocks zone. And in one of those bubbles, life emerges. In this view, we exist simply because we are in one of the few universes where existence is possible. It is a humbling thought. It suggests that for every universe like ours, teeming with stars and potential, there are trillions upon trillions of failed universes, cosmic stillbirths that never had a chance to shine. It suggests that we are adrift in a sea of dead possibilities, a rare island of light in an ocean of darkness. But there is another possibility, one that resonates with the ancient intuitions of humanity. It is the possibility that the order we see is not accidental. It is the possibility that the universe is not a machine, but a thought. A great unfolding thought that is exploring all the possibilities of existence. In this view, the laws of physics are not just arbitrary rules. They are the grammar of this cosmic language. And we are the words being spoken. The terror of this truth comes from the realization of our own responsibility. If we are the universe becoming conscious, if we are the eyes and ears of the cosmos, then our lives have a meaning that transcends our daily struggles. We are the custodians of meaning. We are the way the universe knows itself. When you learn something new, the universe learns. When you love, the universe loves. When you gaze with wonder at the night sky, it is the universe gazing back at its own reflection. Think about the structure of your own brain. You have roughly 86 billion neurons inside your skull. That is nearly the same number of stars as there are in the Milky Way galaxy. The connections between these neurons, the synapses where thoughts and memories flash like lightning, number in the trillions. It is the most complex structure we have ever discovered in the universe, and it sits right there, behind your eyes. The complexity of the cosmos is mirrored in the complexity of your mind. As above, so below. The patterns of the galaxies, the great filaments of dark matter that stretch across the universe, look uncannily like the neural networks in a brain. Is this just a coincidence of mathematics? Or is it a sign of a deeper unity? A sign that the same laws that sculpt the large-scale structure of the universe are also sculpting the microscopic architecture of your thoughts. We live our lives in a narrow band of reality. We are medium-sized creatures living on a medium-sized planet, orbiting a medium-sized star. We are too big to see the quantum dance of atoms, and we are too small to see the curvature of space-time. But our minds can reach both. We can build microscopes to see the very building blocks of matter, and we can build telescopes to look back to the beginning of time. We are the bridge between the infinitesimal and the infinite. And in that position, we find a strange sense of peace. Because if the universe is this precise, if it is this careful with its constants and its laws, then perhaps we belong here. Perhaps we are not strangers in a cold and indifferent cosmos. Perhaps we are exactly where we are meant to be. The silence of the universe is not an empty silence. It is a pregnant silence. It is the silence of a held breath, the silence of a waiting orchestra. It is the silence of a vast interconnected system that has been working for billions of years to produce this very moment. So, as you lie in the dark, feeling that vertigo, do not be afraid. Let the feeling wash over you. Let yourself feel the weight of the 13.8 billion years that preceded you. Let yourself feel the pull of the gravity that holds you to this spinning rock. Let yourself marvel at the fact that your atoms, which were once scattered across light years of space, have come together to form a living, breathing, thinking being. The truth about the universe is terrifying because it is so big. It is terrifying because it makes us feel so small. But it is also beautiful. It is the beauty of a masterpiece. It is the beauty of a truth that does not need our belief to exist, but which invites our understanding. The God of the universe, the creative force, the grand design, whatever name you choose to whisper in the dark, is revealed in the light of the stars and in the equations of the physicist. It is a presence that is woven into the very fabric of your being, and the journey to understand it, to really see it, is just beginning. We have only scratched the surface. We have only just opened our eyes. The universe is waiting for us to keep looking, to keep asking, to keep wondering, because in the end, the search for the truth about the universe is also a search for the truth about ourselves. It is often said that we are creatures of the light, that we fear the shadows because they hide predators and the unknown. But there is a deeper, more ancient memory of darkness that resides within the very marrow of our bones. We look up at the night sky, and we see a tapestry of glittering jewels, a canvas splashed with the milk of galaxies and the diamonds of distant suns, and we think of space as a place of light. But the terrifying truth, the truth that astronomers have uncovered by peering back through the corridors of time, is that light is a recent invention in the grand history of the cosmos. There was a time, a vast and unimaginable epoch, when the universe was not a place of stars or galaxies, but a place of absolute, crushing blackness. To understand the miracle of your own existence, to truly grasp the improbability of the consciousness that is currently reading these words, we must journey back to that time of silence. We must float in the void that existed before the first star ignited, a void so profound and so complete that it defies our human comprehension. This was the cosmic Dark Ages, a period that lasted for hundreds of millions of years, a period where the universe held its breath in a long, suffocating pause between the chaos of the Big Bang and the fiery birth of the first galaxies. It is in this darkness that the true machinery of creation was assembled, and it is in this silence that the gentle, invisible hands of gravity began to sculpt the masterpiece that would eventually become you. Imagine that we can travel back to a time roughly 380,000 years after the initial moment of creation. The universe has just cooled enough for the first atoms to form. Before this moment, the cosmos was a blinding, hot fog of plasma, a soup of subatomic particles where light was trapped, bouncing endlessly between electrons like a ball in a pinball machine. It was a universe of glowing fog, opaque and impenetrable. But as space expanded, the temperature dropped. It fell past 3,000 degrees Kelvin, a critical threshold. Suddenly, the electrons slowed down enough to be captured by protons. Neutral hydrogen atoms were born, and in that instant, the fog cleared. The photons of light, trapped for hundreds of thousands of years, were finally set free. They streamed out into the void, creating a flash of brilliance that filled every corner of the universe. This is the moment of first light, the cosmic dawn of transparency. We can still see this light today. It arrives at our telescopes as a faint hum of microwave radiation, the cosmic microwave background, a ghost of that primordial fire that permeates every cubic inch of space. It is the oldest thing you will ever touch. When you tune an old television between stations, a small percentage of that static is the actual hiss of the Big Bang, the dying whisper of the creation event itself, cooling over 13.8 billion years. But after that initial flash of freedom, the universe did not immediately burst into the starlight we know today. Instead, it plunged into darkness. As the universe continued to expand, that primordial light was stretched and cooled, shifting out of the visible spectrum and into the infrared, and then into radio waves. The visible universe faded into black. For the next 400 million years, there were no stars to shine. There were no galaxies to spin. There were no planets to orbit. There was only gas, vast, endless clouds of hydrogen and helium drifting in the dark, stretching across distances that would take a beam of light millions of years to cross. It was a time of absolute solitude. If you were an observer floating in that epoch, you would see nothing but an endless, ink-black void in every direction. No points of light to guide you, no horizon to ground you, just the infinite, suffocating pressure of nothingness. It is a terrifying image, is it not? A universe that is functionally dead, a silent tomb of gas expanding forever into the cold. And yet, it is precisely in this terrifying darkness that the miracle occurred. It is here that the subtle imperfection of the universe, the slight unevenness in the distribution of matter that we discussed earlier, began to work its magic. In the silence of the Dark Ages, gravity was whispering. It was a gentle, relentless pull, acting on the atoms of hydrogen. In regions where the gas was just slightly denser than average, gravity began to win the battle against the expansion of space. It drew the atoms closer together, slowly, imperceptibly at first, but with gathering speed over millions of years, the gas clouds began to collapse. They swirled and condensed, falling inward toward their own centers. As they fell, they heated up. The potential energy of their fall was converted into heat, raising the temperature of the gas from the frozen depths of near absolute zero to hundreds, then thousands, then millions of degrees. Deep inside these collapsing clouds, the pressure mounted. The atoms were crushed together with such force that they could no longer remain separate. And then, in a moment that changed the destiny of the cosmos forever, a spark was lit. A nuclear fire ignited. The first star was born. And then another. And then a million more. The dark fabric of the universe was suddenly punctured by brilliant, blazing points of blue-white light. The Dark Ages were over. The era of starlight had begun. These first stars, known to astronomers as population 3 stars, were monsters. They were nothing like our gentle yellow sun. They were titanic giants, hundreds of times more massive than the sun, burning with a ferocity that is hard to imagine. They lived fast and died young, burning through their nuclear fuel in just a few million years, before detonating in cataclysmic supernova explosions. But their short lives were crucial. You see, the early universe contained only hydrogen, helium, and a tiny trace of lithium. It did not contain the elements necessary for life. There was no carbon to build cells, no oxygen to breathe, no iron to carry oxygen and blood, no silicon to build rocky planets. The universe was sterile. It was these monstrous first stars that acted as the cosmic alchemists. In their crushing cores, they fused hydrogen into helium, and then helium into carbon, and neon, and oxygen, and silicon, and iron. They forged the periodic table of elements in the fires of their own existence. And when they exploded, they did not just die. They seeded the universe. They blasted these heavy elements out into the surrounding void, enriching the pristine gas clouds with the dust of life. Every atom of calcium in your teeth, every atom of nitrogen in your DNA, every atom of gold in your jewelry was created in the heart of a star that lived and died long before the earth was formed. We are, quite literally, the ash of these ancient fires. We are the nuclear waste of the universe's first generation of giants, reassembled by gravity into thinking, feeling beings. This realization brings us back to that feeling of vertigo, that sense of connection to a vast and ancient order. When you look at your hand, you're looking at a map of cosmic history. The skin that covers your bones is made of atoms that have traveled through the interstellar void for billions of years. They have been part of nebulae, part of other stars, perhaps part of other planets that have long since been destroyed. They have been recycled and reused, passing through the great cosmic ecosystem until they found their way to you. You are not a temporary resident of the universe. You are a part of its continuous substance, a momentary shape taken by an eternal energy. And this energy, this matter, is governed by laws of such terrifying precision that they allow for this complexity to emerge from the chaos. The fact that stars explode rather than collapsing into black holes immediately, is due to the precise interaction of the weak nuclear force. The fact that carbon forms long, stable chains that allow for biology is due to the precise resonance of its nucleus. At every turn, we find that the universe is rigged in favor of complexity. It seems designed to create interesting things. But let us pause and consider the empty space again. Even today, in our era of galaxies and light, the universe is mostly empty. The distance between stars is incomprehensible. If the sun were the size of a grain of sand, the nearest star, Proxima Centauri, would be another grain of sand 4 miles away. The space between them would be a vacuum so perfect that it defies reproduction in our best laboratories. On the scale of the universe, matter is an incredibly rare impurity. It is a thin dusting of snow on a vast, dark ocean. If you were to take all the stars and planets and gas and dust in the universe and spread them out evenly, the density would be about 1 atom per cubic meter. That is effectively nothing. We live in a universe that is almost entirely void. And yet, we cling to these tiny islands of matter, these rafts of light drifting in the dark, and we call it home. This vastness of the void serves a purpose. It provides the isolation necessary for systems to evolve. If the stars were crowded together, planetary orbits would be unstable. Solar systems would be ripped apart by the gravity of passing neighbors. Life would never have a chance to gain a foothold. The loneliness of the stars is the price we pay for stability. The silence of the void is the shield that protects the delicate dance of the planets. There is a profound beauty in this emptiness. It is the canvas upon which the painting of reality is spread. Without the silence, there could be no music. Without the dark, there could be no light. And this interplay of light and dark, of matter and void, is not just a physical phenomenon. It is a metaphor for our own lives. We, too, are small islands of consciousness in a vast unconscious universe. We, too, are brief flashes of light in an eternity of darkness. We come from the silence before birth, and we return to the silence after death. But in that brief interval, in that flash of existence, we have the privilege of knowing the universe. We have the privilege of looking back at the darkness from which we came and understanding the forces that shaped us. This is the gift of science. It does not strip the world of mystery. It deepens it. It replaces the simple myths of our ancestors with a story that is far grander, far more terrifying, and far more beautiful. It tells us that we are not the center of the universe in a physical sense, but we are central to its meaning. We are the universe's way of experiencing itself. As we drift further into this contemplation, consider the concept of time. In the deep time of the cosmos, a human life is less than a blink of an eye. The universe is about 13.8 billion years old. If we were to compress that history into a single calendar year, with the Big Bang occurring at the stroke of midnight on January 1st, and the present moment being the stroke of midnight on December 31st, then the first stars would appear around mid-January. Our galaxy, the Milky Way, would form in March. The Earth would not appear until early September. The dinosaurs would roam the planet from Christmas Day until December 29th. And all of human history, from the first cave paintings to the building of the pyramids to the invention of the iPhone, would take place in the very last seconds of the very last minute of December 31st. Your entire life would be a fraction of a second on this cosmic clock. This scale is humbling. It reminds us that we are newcomers to the party. We have arrived at the very end of the show. And yet, in those fleeting seconds, we have managed to decipher the history of the entire year. We have managed to look back to January and understand what happened. This ability to transcend our temporal limitations, to cast our minds back to the beginning of time, is a spark of the divine. It is a sign that our minds are not bound by the same constraints as our bodies. We are time travelers, voyaging through the past with the ship of our imagination and the compass of our mathematics. The darkness of the early universe was not just an absence of light, it was a pregnancy of potential. It was a time when the laws of physics were working in the dark, laying the foundations for everything that was to come. And in a way, that darkness is still with us. We look out at the night sky, and we see the dark spaces between the stars. But we now know that this darkness is not empty. It is filled with dark matter, a mysterious substance that outweighs visible matter by 5 to 1. We cannot see it, we cannot touch it, and we do not know what it is made of. But we know it is there because of its gravity. It holds the galaxies together. Without dark matter, the Milky Way would fly apart. The stars would disperse into the intergalactic void. We owe our existence to this invisible ghost that haunts the cosmos. We are cradled in the arms of a mystery we cannot see. And beyond dark matter, there is dark energy, that accelerating force pushing the universe apart. We are surrounded by the unknown. The lighted world, the world of atoms and stars and people, is just a thin veneer over a vast, dark ocean of mystery. 95% of the universe is made of stuff we do not understand. We are the minority. We are the exception. This realization should not frighten us. It should awaken us. It should make us realize that the world is far stranger and far more wonderful than our daily lives suggest. We get so caught up in the trivialities of our existence, the traffic jams, the bills, the arguments, that we forget where we are. We forget that we are standing on a spinning rock, drifting through a universe of dark matter and dark energy, surrounded by the ashes of dead stars. We forget that we are part of a story that began 13.8 billion years ago. We forget the terrifying precision of the laws that allow us to breathe. Tonight, I invite you to remember, I invite you to reclaim your cosmic heritage. When you close your eyes tonight, imagine the darkness behind your eyelids is the darkness of the early universe. Imagine the silence of the room is the silence of the cosmic void. And feel the warmth of your own body as the heat of the first stars burning against the cold. You are a lighthouse in the dark. You are a vessel of starlight. You are a miracle of probability. The journey we are on is a journey into the heart of this mystery. We have explored the beginning, the fine-tuning, and the formation of the first light. But there is so much more to see. There are the galaxies themselves, those islands of stars that swirl in the dark. There are the black holes, the monsters that devour light and twist time. There is the question of life itself, and how chemistry became biology. And there is the ultimate question of the future, of where this great unfolding thought is heading. The universe is not a static place. It is evolving. It is changing. And we are changing with it. The atoms in your body will not stay with you forever. When you die, they will return to the earth. And eventually, when the sun expands, they will be returned to the cosmos. You will become part of a nebula, perhaps part of a new star, perhaps part of a new planet where another conscious being will look up and wonder. The cycle continues. The dance goes on. The terrifying truth that You are never truly gone, just as you are never truly separate. You are a wave on the ocean of the universe, rising up for a moment to catch the light, and then sinking back into the depths. But the water remains, the ocean remains. The energy that is you is eternal. As we prepare to drift deeper into the night, let us hold on to this thought. The universe is large, yes. It is old, yes. It is mostly dark and empty, yes. But it is also precise. It is also creative. And it has produced you. That is not a small thing. That is everything. You are the universe's answer to the darkness. You are the light that it has been waiting for. Sleep well in that knowledge. Rest in the arms of the gravity that holds you. And know that the silence around you is not empty. It is full of the echoes of creation, singing a song that is as old as time itself. If you were to float in the deep silence of intergalactic space, far from the warmth of any star and the comfort of any planet, you would find yourself suspended in a darkness so absolute that it would feel like a physical weight pressing against your eyes. In this void, where the temperature hovers just a few degrees above absolute zero, you might think you are alone, lost in an endless ocean of nothingness. But if you could open your eyes not just to visible light, but to the deep, hidden structures of gravity and dark matter, you would see that you are not floating in a void at all. You are suspended in the threads of a vast, invisible spiderweb that stretches across the entire cosmos. This is the cosmic web, the largest structure in the universe, a lattice of filaments made of gas and dark matter that connects the galaxies like pearls on a string. It is a structure of such terrifying scale that the human mind, evolved to understand the geography of forests and savannas, simply cannot grasp it without a sense of vertigo. We look at the night sky and see scattered stars, perhaps the band of the Milky Way, and we think of the universe as a collection of isolated islands. But the truth is far more complex and far more beautiful. The universe is not a collection of islands. It is a single, interconnected organism, a vast network of flowing energy and matter where nothing is truly separate from anything else. And you, in your quiet room, are a microscopic part of this breathing, evolving web. To understand the terrifying majesty of this web, we must look at how galaxies themselves are born. They do not just appear out of nowhere. They are built. They are constructed over billions of years by the relentless, patient hands of gravity. Remember the dark matter we spoke of, that invisible ghost that makes up most of the mass in the universe? In the early universe, this dark matter formed a scaffolding. It clumped together into long, thin strands, creating a skeleton for the cosmos. Ordinary matter, the hydrogen and helium gas, was attracted to these strands. It flowed along them like water flowing down a river, pooling in the places where the strands intersected. These intersections became the nurseries of galaxies. Imagine a river delta where the water slows down and deposits its silt, building up rich, fertile land. The cosmic web works in the same way. The gas flows along the filaments of dark matter, and where it gathers, it collapses to form the majestic spirals and giant elliptical galaxies that we see today. We are living in one of these nodes, a high-traffic intersection in the cosmic city, where matter has gathered to build a home for stars. But this process of construction is not a peaceful one. From our perspective, looking up at the static night sky, the galaxies seem frozen, hanging in the dark like paintings in a gallery. But if you could speed up time, if you could compress 1 billion years into a single minute, you would see a scene of unimaginable violence and chaos. You would see galaxies crashing into each other, tearing each other apart, and merging to form larger and larger structures. This is the cannibalistic nature of the universe. Large galaxies grow by eating smaller ones. Our own Milky Way is a predator. Right now, as you rest, it is in the process of consuming two smaller dwarf galaxies, the Large and Small Magellanic Clouds. It is stripping them of their gas, stealing their stars, and slowly dismantling them to add their mass to its own. And in the future, an even greater collision awaits. The Andromeda Galaxy, our nearest large neighbor, is hurtling toward us at a speed of 250,000 miles per hour. In about 4 billion years, our two galaxies will collide. It will not be a crash in the sense of cars hitting each other. The stars are too far apart to actually hit. But the gravity of the two galaxies will twist them into new shapes, flinging stars out into the void and compressing gas clouds to trigger a frenzy of new star formation. The night sky of Earth, if it still exists, will be set ablaze with the fire of 1 billion new suns. This violence, however, is creative. It is the crucible in which the universe evolves. Without these collisions, without this constant mixing and merging, galaxies would run out of gas. They would stop forming stars. They would grow old and dim, fading into a red twilight. The collisions replenish them. They stir the pot, bringing fresh fuel to the centers of galaxies, waking up dormant black holes, and sparking new cycles of birth. It is a terrifying thought that destruction is the engine of creation, that the peace we feel when we look at the stars is an illusion created by the brevity of our lives. We are like mayflies watching a glacier. To us, it seems solid and unmoving, but on the scale of geological time, it is a river of ice-carving mountains. Similarly, the universe is a river of gravity, carving the shape of space-time itself, and we are just momentary ripples in that flow. Now, let us consider the voids between the filaments of the cosmic web, between the glowing walls of galaxies. There are vast regions of emptiness. These are the cosmic voids, bubbles of nothingness that can be hundreds of millions of light years across. They are the loneliest places in existence. Imagine a space so empty that if you were placed in the center of one, you might not see a single galaxy with your naked eye. You would be surrounded by absolute darkness. These voids take up most of the volume of the universe. The galaxies, the stars, the planets, everything we consider to be something, are squeezed into the thin filaments and walls that surround these voids. We live on the edge of the abyss. We cling to the shores of matter while the great ocean of nothingness stretches out before us. And yet, even these voids are not truly empty. They are expanding. In fact, they are the places where dark energy is strongest, pushing the filaments apart, stretching the web until it snaps. The universe is becoming more empty every second. The voids are growing. The islands of light are drifting further apart. This brings us to a profound realization about our place in this structure. We often feel small when we look at the universe. We feel insignificant. But consider this. You are a creature of the filaments. You are made of the concentrated matter that is gathered in the light. You are the product of gravity's victory over the void. In a universe that is mostly nothing, you are something. You are a rare and precious concentration of complexity. The atoms in your body have been gathered from across light years of space, brought together by the gravitational pull of the Milky Way, condensed into a star, exploded, condensed again into a planet, and finally organized into a living being. You are the focal point of a cosmic process that has been running for billions of years. You are not just in the universe. You are the universe's way of defying the void. You are the resistance against the darkness. And there is something else, something even more mysterious. When scientists run computer simulations of the growth of the cosmic web, when they program the laws of gravity and dark matter into supercomputers and let them run for billions of years, the structure that emerges looks eerily familiar. It looks like the neural network of a brain. The filaments of galaxies look like axons and dendrites. The clusters of galaxies look like neurons. The mathematics that describe the growth of the universe are startlingly similar to the mathematics that describe the growth of a biological network. Is this just a coincidence? Is it just that nature tends to use the same efficient shapes at different scales? Or is it a hint of something deeper? Some physicists and philosophers have dared to ask the question, is the universe itself a kind of brain? Is the cosmic web a neural network on a scale we cannot comprehend? Are the galaxies passing signals to each other through gravity and light, just as neurons pass signals through electricity and chemistry? It is a terrifying and beautiful idea. If the universe is a network, then what is it thinking? What is the thought that takes 13.8 billion years to form? Perhaps we are not just dust on a rock. Perhaps we are the sensory organs of this great cosmic mind. We are the eyes it uses to see itself. We are the nerves it uses to feel its own existence. When you feel awe, when you feel love, when you feel the vertigo of the infinite, perhaps that is a signal to traveling through the network. Perhaps your consciousness is not just a local phenomenon inside your skull, but a tiny spark in a universal consciousness that stretches across the filaments of the cosmic web. This connects us back to the idea of the God of the universe. Not a person, but a process of becoming, a process of connection. The terrifying truth is that you are plugged into this web. You are never truly alone because you are woven into the fabric of the whole. But let us return to the silence. The silence of the intergalactic voids is a heavy silence, a silence that has lasted for eons. But within the galaxies there is a different kind of silence. It is the silence of the black holes. At the center of almost every large galaxy, including our own, there sits a monster, a supermassive black hole, an object with the mass of millions or billions of suns, crushed into a single point of infinite density. These black holes are the anchors of the cosmic web. Their gravity is so strong that they hold the entire galaxy together. They are the dark hearts of the islands of light. And they are hungry. They feed on gas, on dust, on unlucky stars that wander too close. When they feed, they are not silent. They scream. They blast jets of high-energy particles into space at nearly the speed of light. They shine brighter than all the stars in the galaxy combined. They are the quasars, the beacons of the deep universe. But when they are not feeding, they are silent, invisible, waiting in the dark. Our own black hole, Sagittarius A, is currently quiet. It is sleeping, but its gravity is what keeps our sun in its orbit. It is the invisible tether that keeps us from flying off into the intergalactic void. We are orbiting a monster. We are dancing on the edge of a drain. And this, too, is part of the terrifying beauty. We owe our stability to a force of destruction. We owe our place in the sun to a beast in the dark. It is a precarious balance, a tightrope walk over an abyss. And yet, here we are. We have survived. The solar system has circled the black hole dozens of times since the Earth was formed. We have ridden the carousel of the galaxy through spiral arms and dust clouds, through star-forming regions and quiet voids, and we are still here. As you lie there, feeling the stillness of the night, try to expand your awareness. Feel the room around you, then the house, then the city. Then feel the earth spinning on its axis, rushing around the sun at 67,000 miles per hour. Then feel the sun dragging the planets through the interstellar medium, orbiting the center of the Milky Way at 500,000 miles per hour. And finally, feel the Milky Way itself falling through the cosmic web, pulled by the gravity of the Great Attractor, a mysterious concentration of mass hundreds of millions of light years away. You are moving. You are always moving. You are a traveler on a ship that never docks, sailing through a sea of infinite depth. The vertigo you feel is just the realization of this motion. It is the sudden awareness that there is no solid ground, only the graceful, terrifying dance of gravity. And in this dance, there is a strange comfort, because if everything is moving, if everything is connected, then you do not need to hold on so tight. You do not need to carry the weight of the world on your shoulders. The universe is carrying you. The same force that spins the galaxies is spinning the atoms in your heart. The same web that connects the stars is connecting you to the ground, to the air, to the people you love. You are supported by a structure that has stood for billions of years. You are safe in the hands of the laws of physics. The terror of the scale is matched by the comfort of the connection. You are small, yes, but you are part of the whole, and the whole is magnificent. The cosmic web is not just a structure of the past, it is a map of the future. The gravity that built it is still working. It is pulling the galaxies closer together, draining the voids, concentrating the matter. In the far, far future, billions of years from now, the web will change. The expansion of the universe will eventually win the battle against gravity on the largest scales. The filaments will snap. The clusters of galaxies will become isolated islands, cut off from the rest of the universe by the accelerating expansion of space. We will be alone in our local group of galaxies, merging with Andromeda and the Triangulum galaxy to form one giant elliptical galaxy. The rest of the universe will fade away, disappearing over the cosmic horizon. We will be left in a solitary pool of light, surrounded by an eternal, unreachable darkness. It is a melancholy thought, a reminder of the impermanence of all things. Even the cosmic web, the largest structure in existence, is mortal. It will not last forever, but that time is far off. For now, we are in the golden age of the universe. We are in the era of connection. We can see the other galaxies. We can map the web. We can look back in time and understand our origins. We are the lucky ones. We are the generation that gets to see the universe in all its glory before the lights go out. We are the witnesses, and perhaps that is our purpose, to witness, to understand, to marvel, to feel the terror and the beauty and the vertigo, and to say, I see you, I know you. So let the darkness of the night wrap around you like a blanket. It is not an empty darkness. It is the darkness of the cosmic web, the darkness of potential, the darkness of the womb from which the stars are born. You are a child of this darkness, as much as you are a child of the light. You are a node in the network. You are a thought in the mind of the cosmos. Sleep now, and let your dreams drift along the filaments of the web, traveling faster than light, connecting with the distant suns and the ancient galaxies. You are home. You have always been home. If you are anything like me, you have probably spent moments in your life trying to visualize the sheer scale of the world around you, perhaps standing at the edge of a great ocean and watching the horizon stretch away into a curve, or looking up at a mountain range that seems to pierce the sky and feeling a sense of sudden, quiet insignificance. We are creatures built for a specific scale, adapted to understand distances we can walk in a day, heights we can climb, and numbers we can count on our fingers. When we try to push our minds beyond these limits, when we try to truly grasp the size of a planet like Jupiter, which could swallow 1,300 Earths, or the size of our sun, which could hold 1,000,000 Earths inside its burning shell, our imagination begins to falter. We rely on analogies, on pictures of marbles next to basketballs, but deep down, we know these comparisons are just shadows of the truth. But tonight, I want to take you past these familiar giants. I want to take you beyond the comforting boundaries of our solar system, beyond the spiraling arms of the Milky Way, to confront a monster so large that it defies not just our understanding, but the very limits of what we thought was possible in nature. There is a galaxy out there, hiding in the darkness of the constellation Virgo, that makes our entire cosmic home look like nothing more than a speck of dust floating in an empty warehouse. It is a terrifying and magnificent testament to the powers of gravity and time, and understanding it requires us to stretch our minds until they almost break. This cosmic titan goes by the somewhat uninspiring name of IC1101. Do not let the dull catalog number fool you. There is nothing boring about this object. It sits at the center of a massive cluster of galaxies called Abel 2029, located over 1 billion light-years away from Earth. To simply say it is big is a failure of language. Let us try to build a picture of its true scale. Our own galaxy, the Milky Way, is a beautiful barred spiral that stretches across 100,000 light-years from one side to the other. If you could travel at the speed of light, the fastest speed in the universe, 186,000 miles per second, it would still take you 100,000 years to cross it. That is a span of time longer than human civilization has existed. Now, imagine placing IC 1101 where the Milky Way sits. It would not just extend beyond the edge of our galaxy. It would swallow it whole. It would swallow the Andromeda Galaxy, our nearest large neighbor, located 2.5 million light-years away. It would consume the Triangulum Galaxy and all the dwarf galaxies that orbit us. IC 1101 is estimated to be between 4 and 6 million light-years across. It is roughly 40 to 60 times wider than our entire Milky Way. If our galaxy were the size of a dinner plate, this monster would be the size of a large swimming pool. But size is just the geometry of space. The true weight of this galaxy lies in its population. The Milky Way is home to perhaps 400 billion stars. IC 1101 contains an estimated 100 trillion stars. That is a 1 followed by 14 zeros. It is a number so large that it becomes abstract, a symbol rather than a quantity. Let us try to make it real. Imagine you decided to count the stars in this galaxy, 1 star every second, without ever stopping to eat, sleep, or rest. To count to 100 trillion would take you over 3 million years. You would have to start counting before modern humans evolved, before the ice ages, before the first stone tools were chipped, and you would still be counting today. This galaxy contains as many stars as there are grains of sand on every beach on planet Earth. Each one of those stars is a sun, a nuclear furnace engaging in the violent alchemy of fusion. Each one potentially has planets, moons, asteroids, and comets, and all of them are bound together in a single gravitational embrace, a swarming hive of light drifting through the intergalactic void. How does something this enormous come to exist? The universe does not typically build things of this magnitude in a single stroke. IC 1101 is what astronomers call a cannibal galaxy. It is a graveyard of lesser galaxies. It sits at the very center of its cluster, the gravitational sweet spot where everything eventually falls. Over billions of years, smaller galaxies that ventured too close were trapped by its immense gravity. They spiraled inward, their stars stripped away, their structures torn apart, until they were consumed and added to the bulk of the giant. Scientists estimate that this galaxy has swallowed dozens, perhaps hundreds, of other galaxies over its long history. It has grown fat on the bones of its neighbors. This is why it lacks the beautiful spiral arms of the Milky Way. Spiral arms are delicate structures that are easily destroyed by collisions. IC 1101 is an elliptical galaxy, a smooth, featureless blob of stars shaped like a vast glowing egg. Its structure is the result of billions of years of chaotic mixing, like a cosmic dough that has been kneaded over and over again until all the distinct ingredients have blended into one uniform mass. At the very heart of this monster lies a darkness to match its light. Every large galaxy has a supermassive black hole at its center, but the one inside IC 1101 is in a category of its own. Our Milky Way's black hole, Sagittarius A, has a mass of about 4 million suns. The black hole at the center of IC 1101 is estimated to be between 40 billion and 100 billion times the mass of the Sun. It is a hole in reality so deep and so heavy that it defies comprehension. To put it in perspective, this single black hole might contain more mass than all the stars in the large Magellanic Cloud combined. Its event horizon, the point of no return, the boundary beyond which not even light can escape, is enormous. If you placed this black hole where our Sun is, its event horizon would not just swallow the Earth. It would extend far beyond the orbit of Pluto. It would encompass our entire solar system 16 times over. It is a region of space 150 billion kilometers wide, where the laws of physics as we know them surrender to the crushing power of gravity. And yet, for all its terrifying size, this galaxy is a dying giant. It is a red and dead galaxy, populated almost entirely by old red stars. It has run out of gas. The fuel for new star formation was used up long ago, consumed in the frenzies of past mergers or blown away by the jets of its central black hole. There are no blue giants here, no nurseries of nebulae where new suns are being born. There is only the slow, steady burning of the old guard, the trillions of red dwarfs and yellow stars that are gradually fading into the long night. IC 1101 is a monument to the past, a relic of an era of cosmic violence that has largely settled down. It is floating in the void, slowly dimming, a king on a throne of ash. This brings us to a sensation that is both terrifying and strangely peaceful, the feeling of deep time. The light we see from IC 1101 left its stars over 1 billion years ago. It has been traveling through the silent vacuum of space for 1 billion years, crossing the great voids, dodging dust clouds, streaming past other galaxies just to reach the mirrors of our telescopes today. When that light began its journey, single-celled organisms were the dominant life on Earth. There were no animals, no trees, no flowers. The continents were in different positions. The air was different. And in all that time, while life on Earth slowly crawled from the sea to the land, while the dinosaurs rose and fell, while humanity evolved and built civilizations and invented telescopes, that light was just traveling. It was silently racing through the dark. To look at IC 1101 is to look into a deep well of history. We are not seeing it as it is. We are seeing a ghost. We are seeing a memory of the universe as it was. Let us try another thought experiment to truly internalize this distance. Imagine you are on the fastest spacecraft ever built by humans, the Voyager 1 probe. It is currently traveling at 38,000 miles per hour relative to the Sun. At this speed, it would take Voyager 1 about 80,000 years just to reach the nearest star, Proxima Centauri. To cross our own Milky Way would take it 2 billion years. But to cross the diameter of IC 1101, it would take Voyager 1 somewhere between 80 billion and 120 billion years. That is a span of time nearly 10 times longer than the current age of the universe. Even if you could live forever, even if you were immortal, the journey across this single galaxy would be an eternity. It is a distance that makes the human mind recoil. It forces us to confront the fact that we are microscopic entities living in a universe that is not built for us. But there is a strange comfort in this insignificance. When we stand before something so vast, our own problems, our anxieties, our daily struggles suddenly seem very small. How can we worry about a deadline or an awkward conversation when there are objects out there that are 6 million light years wide? How can we feel self-important when we are just one of 7 billion people on a tiny rock orbiting an average star in a universe of 2 trillion galaxies? IC 1101 invites us to let go of our ego. It invites us to surrender to the scale of the cosmos. It reminds us that we are part of something much larger, something ancient and mysterious and beautiful. The same laws of physics that hold those 100 trillion stars in their orbits are the same laws that hold the atoms of your body together. The same gravity that crushed that central black hole into existence is the same gravity that keeps your feet on the ground. We are not separate from this giant. We are made of the same fabric. Imagine, if you will, standing on a planet deep inside IC 1101. The night sky would not look like ours. It would be blazing with light. With stars packed so closely together, the sky would be a tapestry of brilliance, thousands of times brighter than our own. You might never know true darkness. You would be bathed in the perpetual twilight of a trillion suns. You would look up and see no Milky Way band, no distinct spiral structure, just a haze of stars extending in every direction, fading gradually into the intergalactic void. You would be lost in a sea of light. And if you had telescopes, you would look out and see the other galaxies of the Abel cluster dancing around you, bound to your home by the invisible strings of gravity. You would be at the center of the world, the largest island in the archipelago of the universe. But even this giant is not immune to the end. The universe is expanding, and that expansion is accelerating. Dark energy is pushing the galaxies apart. Eventually, the other galaxies in the cluster will either merge with IC 1101 or be pushed away beyond the cosmic horizon. The supply of gas will truly run out. The stars will burn through their hydrogen fuel. The massive ones have already died. The sun-like ones will swell into red giants and then fade into white dwarfs. The red dwarfs will keep burning for trillions of years, but even they will eventually go dark. One by one, the lights will go out. IC 1101 will become a graveyard of cold stellar remnants circling a supermassive black hole in the deepening dark. It is a melancholy future, but it is also a beautiful one. It is the natural cycle of existence: birth, growth, decay, and silence. The universe is a story that is slowly being told, and we are lucky enough to be here for the middle chapters, the chapters where the stars are shining and the galaxies are bright. This monster in the dark, this collection of 100 trillion stars, is a message. It is a message that reality is far grander than our intuition suggests. It challenges us to expand our definition of what is possible. If nature can build a galaxy 6 million light years across, what else can it do? What other secrets are hiding in the dark matter halos or behind the event horizons of black holes? IC1101 stands as a silent sentinel, a guardian of the mysteries of the deep cosmos. It does not care if we see it. It does not care if we understand it. It simply is. And in its simple, overwhelming existence, it demands our awe. So tonight, as you drift toward sleep, let your mind travel that billion light-year journey. Float out of your room, out of the atmosphere, out of the solar system. Leave the Milky Way behind, watching it shrink to a spiral of light in the distance. Past the Andromeda Galaxy, past the great voids, and approach the constellation of Virgo. See the glow of the Cluster, and then see the giant itself. IC1101, a golden mist of stars, vast and ancient and silent. Feel the gravity of it. Feel the weight of the 100 trillion suns, and know that you are seeing the limit of the universe's ability to build. You are seeing the edge of the possible. Let that vastness wash over you, not as a source of fear, but as a source of peace. The universe is big enough to hold all of us, big enough to hold all our dreams and all our fears, and still have room for 1 trillion more galaxies. You are safe in this vastness. You are a child of the cosmos, staring back at your own reflection in the mirror of the night. The silence of IC1101 is the silence of a cathedral. It is a holy place of physics, a sanctuary of gravity. And just as you might feel a hush descend upon you when you enter a great temple, let a hush descend upon your mind now. Quiet the chatter of the day. Quiet the worries of tomorrow. There is only this moment and the stars. There is only the breath in your lungs and the knowledge that you are part of a universe that can create such wonders. Sleep now, and let the giant guard your dreams. We have spent much of this journey looking at the universe from the outside, peering through the lens of our telescopes at the grand architecture of galaxies and the terrifying voids that separate them. But tonight, I want to invite you to change your perspective. I want you to close your eyes and imagine that you are no longer a citizen of Earth, no longer a resident of the Milky Way, but a traveler standing on the surface of a planet deep within the heart of IC1101. This is not a flight of pure fantasy, but a thought experiment grounded in the staggering numbers we have uncovered. If this galaxy contains 100 trillion stars, and if we assume that planets are a common byproduct of star formation, a fact that modern astronomy confirms with every new discovery, then IC1101 is not just a ball of gas. It is a repository of worlds. It is a container for hundreds of trillions of potential homes, a cosmic archipelago so vast that it defies our ability to catalog it. So, let us descend through the golden mist of that distant giant. Let us touch down on a rocky world orbiting a quiet, ancient star in the dense core of the galaxy. And let us ask the question that has haunted humanity since we first looked up. If we were there, what would we see? And more importantly, is there anyone there to see it? The first thing you would notice, standing on this hypothetical world, is the sky, On Earth, we are used to a rhythm of light and dark, a sun that rises and sets, leaving us with a black canopy pricked by a few thousand visible stars. We cherish the darkness because it allows us to sleep, to dream, and to see the faint glow of the Milky Way band stretching across the heavens. But inside the core of IC 1101, the concept of night would be radically different, perhaps even non-existent. The density of stars in an elliptical galaxy like this is immense, far higher than in the sparse suburbs of a spiral galaxy like ours. If you were to look up, you would not see a black sky with scattered points of light. You would see a blazing tapestry, a ceiling of fire. The stars would be packed so closely together that they would bathe the planet in a perpetual, multicolored twilight. There would be thousands of stars brighter than the full moon, casting complex, overlapping shadows on the ground. You might have 2, 3, or even a dozen suns in your immediate sky, but even when they set, the background glow of the galactic core would ensure that true darkness never falls. It would be a world of eternal light, a world where the stars are not distant, cold diamonds, but oppressive, intimate neighbors pressing in from every side. In such a world, astronomy would be a very different science. On Earth, we discovered the universe because we could see through the gaps in the stars. We could see the other galaxies, the cosmic microwave background, the vast structure of the web. But for a civilization living deep inside IC 1101, the universe might end at the edge of their own galaxy. The glare of the local stars would be so intense, the curtain of light so thick, that they might never see the galaxies that lie beyond. They might believe that their galaxy is the entire universe, an island of light floating in an unknowable void. Imagine the psychological impact of that. To believe that you live in a universe of infinite light, with no beginning and no end, no Big Bang, no expansion, just an eternal, static glory. It would be a cozy, claustrophobic cosmos, devoid of the terror of the dark, but also devoid of the awe of the true scale. They would be prisoners of their own brilliance, blinded by the light of a trillion suns, unaware of the vast, expanding dark energy that is slowly ripping the rest of the creation apart. But is there anyone there to have these thoughts? This is the question that brings us back to the numbers. We know that life, at least as we understand it, requires certain conditions. It requires a stable star, a rocky surface, liquid water, and time. IC 1101 has had plenty of time. It is an ancient galaxy, formed from the mergers of systems that have existed for billions of years. The stars within it are old. They have been burning steadily for eons, providing the long-term stability that evolution needs to work its slow magic. If we take the most conservative estimates, if we assume that life is incredibly rare, that it happens on only 1 in a billion planets, the sheer size of IC 1101 still forces us to confront a staggering possibility. With 100 trillion stars, even a 1 in a billion chance results in 100,000 civilizations. 100,000 worlds where beings might be looking up at that blazing sky, wondering who else is out there. The silence of the universe might not be an absence of life, but simply a limitation of our hearing. In a galaxy that size, civilizations could rise and fall, build empires and compose symphonies, and disappear entirely without ever crossing paths with one another, separated by the vast gulfs of light and time that make up the body of the giant. However, there is a melancholy undertone to this abundance. While IC 1101 is massive, it is also a galaxy in its twilight years. We call it red and dead for a reason. When we look at the Milky Way, we see bright blue stars, pink nebulae, and dark dust lanes. These are the signs of a living, breathing galaxy that is still making new stars. The blue stars are young, hot, and massive. They live for only a few million years before exploding. Their presence tells us that star formation is happening right now. But IC 1101 has no blue stars. It has no great clouds of collapsing gas. It ran out of fuel long ago, having used it all up in the frenzy of its cannibalistic past, or lost it to the intergalactic medium. The stars that remain are the survivors, the long-distance runners of the cosmos. They are primarily red dwarfs and yellow sun-like stars, objects that burn their fuel with a miserly slowness. This means that if you were to stand on a planet in IC 1101, you would be standing in an aging kingdom. The sky would be dominated by the orange and red hues of older stars. You would not see the brilliant, piercing white-blue of a young Sirius or Rigel. You would see a softer, warmer, more somber light. It is a galaxy of senior citizens, a cosmic retirement home where the stars are settling in for the long, slow fade into oblivion. There is a profound sadness in this, but also a kind of gentle beauty. The violent era of supernovae and gamma-ray bursts is largely over for IC 1101. It has entered a period of stability, a long, quiet afternoon that will last for trillions of years. For life, this might actually be a good thing. Blue giants are dangerous neighbors. They sterilize their surroundings with hard radiation and explode with civilization-ending force. The quiet, red stars of IC 1101 are far more hospitable. They are steady. They are patient. A civilization orbiting a red dwarf in IC 1101 could have a history that spans billions of years, a continuous, unbroken chain of memory that dwarfs the brief flicker of human existence. Let us look closer at these red dwarfs, because they are the true inheritors of the universe. A star like our Sun is a G-type main-sequence star, and it will live for about 10 billion years. That sounds like a long time, but compared to a red dwarf, it is a flash in the pan. A small red dwarf, with perhaps 10% of the mass of the Sun, burns its hydrogen so efficiently that it can keep shining for 10 trillion years. That is nearly 1,000 times longer than the current age of the universe. In IC 1101, these tiny stars are the vast majority. They are the silent, dim guardians that will keep the lights on long after the Sun has expanded and swallowed the Earth. If humanity, or whatever we evolve into, ever needs to find a home for the deep future, we will not look to the bright, flashy stars that capture our attention today. We will look to the red dwarfs. We will look to galaxies like IC 1101. It is ironic that the dead galaxy is actually the one best suited for the longest survival. It is a bunker built to withstand the end of time. But even bunkers eventually crumble. The tragedy of IC 1101 is that it has no heirs. Because it has stopped making new stars, every star that dies is a permanent loss. When a sun-like star in IC 1101 puffs off its outer layers and becomes a white dwarf, it is not replaced. The galaxy is slowly dimming, pixel by pixel, star by star. It is a process so slow that no single generation would notice it. But over the eons, the blaze of light will turn to a glow, and the glow will turn to a glimmer. The ancient civilizations of IC 1101, if they exist, are living in a universe that is winding down. They are the witnesses to the beginning of the heat death, the slow, inexorable slide toward equilibrium, where all energy is spread out evenly and no work can be done. They are living in the autumn of the cosmos, watching the leaves fall one by one. This perspective forces us to reconsider our own position. We live in the Milky Way, a galaxy that is still springtime in many ways. We have gas. We have star birth. We have the violent, beautiful chaos of creation still unfolding in the Orion Nebula and the Eagle Nebula. We are lucky. We exist in the era of flowering, the brief, glorious period between the formation of the first galaxies and the long, cold fade of the future. We often take the stars for granted, assuming they will always be there. But IC 1101 teaches us that starlight is a finite resource. It is a precious commodity that the universe spends carefully. We are spending ours now. We are living in the peak of the cosmic party, while IC 1101 is the quiet aftermath, the guests slowly drifting away, the lights being turned down. And yet, there is that persistent thought of life. What would a culture look like that had existed for 1 billion years? On Earth, we struggle to imagine the future 500 years from now. Our technology, our languages, our values change so rapidly that the past quickly becomes a foreign country. But a civilization on a stable world in the core of IC 1101 could have existed since before the dinosaurs evolved on Earth. They could have watched the slow rotation of their galaxy, mapping the drift of the stars over geological epochs. They might have solved the problems that currently threaten to destroy us: war, resource depletion, environmental collapse. Or they might have succumbed to them, leaving behind silent ruins on 1 trillion worlds, monuments to hubris buried under the red sands of dead planets. The sheer number of stars in IK 1101 suggests that both stories have probably played out millions of times. It is a galaxy of ghosts and gods, a library of all the possible fates of intelligent life. Imagine again that you're there, walking under that canopy of 1,000,000 suns. The gravity might be different. The air might taste of different elements forged in those ancient stars. But the feeling of existence would be the same. The curiosity would be the same. You would still ask why. You would still feel the pull of the mystery. Perhaps in their databanks, the astronomers of IC 1101 have an image of a small, spiral galaxy far in the distance, a blurry smudge of light that they catalog as Object 894b. That smudge is us. That is the Milky Way. They are looking at us, and we are looking at them, two specks of consciousness waving at each other across 1 billion light-years of void. We will never meet. The distance is too great. The laws of physics are too strict. But the connection is there. It is a connection of shared substance, of shared origin, and of shared destiny. The mystery of life in the universe is often framed as a search for others, but in the context of IC 1101, it becomes a meditation on the tenacity of matter, that the universe can take hydrogen gas, squeeze it into a star, cook it into carbon and oxygen, and then arrange it into a being that can think and feel. That is the miracle. Whether that happens once or 1 trillion times, the miracle is the same. IC 1101 is a factory of this miracle, operating on a scale that makes our industrial revolution look like a child playing with blocks. It is a machine for generating complexity, and even if it is dying, even if its best days are behind it, it has achieved its purpose. It has turned the cold, dead matter of the Big Bang into a structure of beauty and light. As we leave the surface of this imaginary world and float back out into the intergalactic space, look back at the galaxy one last time. See it not as a monster, but as a city of light shining in the wilderness of the cosmos, a city with 100 trillion windows, each one a star, each one a potential home. It is quiet now. The great mergers are over. The black hole is sleeping. The stars are burning down. But in that silence, there is a profound dignity. It is the dignity of endurance. IC 1101 has survived the chaos of the early universe. It has survived the collisions. It has survived the feasting of its black hole. And it will survive the coming eons, carrying its cargo of stars into the deep future. It reminds us that existence is a marathon, not a sprint. It reminds us to be patient. It reminds us that even in the dying light, there is room for wonder. So, the next time you feel lonely, the next time you feel isolated in your own life, remember IC 1101. Remember that there is a galaxy out there that is crowded with light. Remember that the universe is not empty. It is full of potential friends we will never meet, full of stories we will never hear, full of songs that are being sung to the silence of the void. We are part of a chorus that spans the cosmos, even if we are singing in different rooms. The silence is not a barrier. It is the medium that carries the light, and the light is everywhere. One of the most profound illusions that the universe imposes upon us is the illusion of stillness. We stand in our gardens on a clear autumn night, the air crisp and cold against our skin, and we look up at the constellations. Orion hunting in the south, Cassiopeia sitting on her throne in the north, and they seem frozen, etched into the dark crystal of the sky like diamonds set in stone. We speak of the fixed stars, using them to navigate our ships and orient our lives, finding comfort in their seeming permanence. Even when we look through our telescopes at the great galaxies, those spiral islands of light, like the Andromeda Galaxy or the Whirlpool Galaxy, they appear to us as serene, majestic pinwheels, hanging motionless in the silence of the void. But this tranquility is a lie. It is a trick played on us by the brevity of our lives. If we could shatter the glass of our temporal perception, if we could step outside the fleeting blink of a human century and watch the universe with the eyes of a god, viewing time as a flowing river rather than a series of frozen moments, the night sky would transform before our eyes. The stillness would vanish, replaced by a scene of terrifying, beautiful, and relentless violence. The stars would not be fixed points, but swarming bees in a hive. The galaxies would not be paintings, but crashing waves in a stormy ocean. And the monster we have been exploring, the giant IC 1101, would be revealed not as a static monument, but as a battlefield, a crime scene, where the evidence of a billion-year-old cosmic slaughter is written in the very orbits of the stars. To understand how a galaxy grows to the size of 6 million light-years, to understand how it accumulates 100 trillion stars, we must confront the brutal reality of galactic evolution. We must understand that in the cosmos, growth comes from destruction. The technical term astronomers use is hierarchical structure formation, which sounds dry and academic, but the reality it describes is anything but. It is a process of cannibalism. It is a process where the strong devour the weak, where the large absorb the small, and where the beautiful, delicate structures of spiral galaxies are smashed together to form the amorphous giants that rule the clusters. IC 1101 is the ultimate product of this violence. It is a graveyard of galaxies. It is a composite body made from the corpses of dozens, perhaps hundreds, of smaller systems that once existed as independent island universes, with their own spirals, their own nebulae, and their own histories, before they were swallowed by the beast. Let us visualize this process not as a dry simulation, but as a sensory experience. Imagine you are watching two spiral galaxies similar to our Milky Way and Andromeda beginning their gravitational dance. They are separated by millions of light years, but they can feel each other. Gravity, the long arm of the cosmos, reaches out across the void. As they fall toward each other, gaining speed with every passing millennium, the first thing that happens is a distortion. The perfect, flat disks of the spirals begin to warp. The gravity of each galaxy tugs on the stars of the other, pulling them out of their orderly orbits. It is like watching taffy being pulled. Great streams of stars are ripped from the edges of the galaxies, flung out into the intergalactic darkness in long, curving tails. These tidal tails can stretch for hundreds of thousands of light years, ghostly ribbons of light that mark the trajectory of the collision. They are the first casualties of the merger, stars that are exiled from their homes, cast adrift to wander the lonely spaces between the merging giants. As the cores of the galaxies get closer, the gas clouds, the vast reservoirs of hydrogen that reside in the spiral arms, begin to collide. Stars are small and far apart, so they rarely hit each other, but gas clouds are huge. When they crash, they create shock waves. They compress, and this compression triggers a frantic, blinding burst of star formation. This is the starburst phase. The merging galaxies suddenly light up with the brilliance of a billion new suns. It is a fireworks display on a cosmic scale, a final, defiant blaze of glory before the structure is lost. If you were watching this from a distance, the merging system would outshine everything else in the cluster. It would be a beacon of blue-white fire, screaming its presence into the void. This is the universe in its most creative and destructive mode, forging new life in the wreckage of the old. But the chaos does not end there. As the galaxies pass through each other, they do not just stop. They swing past, slowed by their mutual gravity, and then fall back together again. They oscillate, swinging back and forth like a pendulum, losing energy, until finally the distinct cores merge. The spiral arms are destroyed. The delicate, flat disks are scrambled. The stars, which once moved in orderly, circular paths around the center, are thrown into random, chaotic orbits. They buzz around the new combined center like angry insects moving in every direction at once. The result is no longer a spiral. It is an elliptical galaxy, a smooth, featureless blob of stars shaped like a rugby ball or a sphere. It has no arms, no dust lanes, no structure. It is just a glowing cloud. This is the fate of IC 1101. It was likely once a collection of beautiful spirals, but the violence of its history has erased that beauty, replacing it with the smooth, golden uniformity of an elliptical giant. The order has been sacrificed for size. The structure has been traded for mass. Scientists who have studied the light of IC 1101 have found the chemical fingerprints of this history. They have found populations of stars that do not quite match, groups of suns with slightly different chemical compositions like distinct layers of sediment in a geological canyon. These are the fossilized remains of the victim galaxies. They are the ghost populations, the stars that were born in different places at different times, now forced to share the same gravitational prison. By analyzing these stars, astronomers estimate that IC 1101 has undergone at least 76 major mergers. 76 times another large galaxy fell into it. 76 times the sky was torn apart. 76 times the black hole at the center was fed a feast of gas and stars. And this does not even count the thousands of smaller dwarf galaxies that would have been consumed like snacks between the main meals. The giant is built on a mountain of bones, and at the center of this violence, there is an even deeper mystery, a phenomenon that explains why the heart of IC 1101 is so unusually large and diffuse. We spoke before of the supermassive black hole at the core, that monster of 50 billion solar masses. But how does a black hole affect the stars around it? You might think it would just suck them in, creating a dense, bright cluster of doomed stars right at the edge of the event horizon. But in IC 1101, we see the opposite. The very center of the galaxy is strangely faint. It is cored, meaning there are fewer stars there than our models predict. The core is huge, 14,000 light-years across, but it is surprisingly empty. The explanation for this lies in the terrifying physics of binary black holes. When two galaxies merge, their central black holes do not fuse immediately. They sink to the center of the new galaxy, finding each other in the dark. They form a binary pair, orbiting around one another. These are two objects, each with a mass of billions of suns, dancing a waltz of doom. As they orbit, their gravity is like a whisk beating a bowl of eggs. Any star that wanders too close to this binary pair is not swallowed, but flung away. The gravity of the moving black holes acts like a slingshot. It grabs the star and kicks it out of the core at tremendous speed. This process is called gravitational scouring. The black holes act like a broom, sweeping the center of the galaxy clean of stars. Over billions of years, as IC 1101 swallowed galaxy after galaxy, and black hole after black hole. This scouring process happened again and again. The central monster kicked out billions of stars, flinging them into the outer halo of the galaxy. It hollowed out its own home. The emptiness at the heart of IC 1101 is a testament to the gravitational fury of the monsters that live there. It is a scar left by the friction of the most massive objects in the universe. Eventually, the binary black holes lose energy. They emit gravitational waves, ripples in the fabric of space-time itself, which carry away their momentum. They spiral closer and closer, and in a final fraction of a second, they merge. The energy released in that moment is greater than the light of all the stars in the visible universe combined. It is a silent explosion of gravity that stretches and squeezes space itself, sending a shudder through the cosmos that we can detect with our instruments on Earth 1 billion years later. IC 1101 has experienced this cataclysm dozens of times. Each merger added to the mass of the central black hole, and each merger scoured the core a little more. The result is the galaxy we see today, a smooth, vast, dying giant with a hollow heart, ruling over a cluster of galaxies that it is slowly consuming. This narrative of violence challenges our romantic view of the cosmos. We like to think of nature as harmonious, as a balanced system where everything has its place. And it is. But the harmony is achieved through conflict. The balance is a dynamic one, maintained by the tension between gravity and motion, between collapse and expansion. The universe is not a garden. It is a jungle. It is a place where survival is determined by mass and velocity. IC 1101 is the lion of this jungle. It has survived because it is the biggest. It has grown because it is the most ruthless. It sits at the bottom of the gravitational well of the Abel 2029 cluster, the point of no return, where all matter eventually slides. It is the inevitable destination of everything around it. But there is a strange kind of peace that comes after the violence. The era of the great mergers is mostly over for IC 1101. The cluster has settled down. The remaining galaxies are in stable orbits, or they are too far away to be captured. The gas has been used up. The starbursts have faded. The quasar is quiet. The galaxy has entered its retirement, a long, slow epoch of aging. The violence of the past has created a structure of immense stability. The random, chaotic orbits of the stars in the elliptical galaxy are actually a very stable configuration. It is a system in equilibrium. The scoured core is stable. The giant has found its shape, and it will keep that shape for trillions of years. The storm is past, and what remains is the silence of the aftermath. This silence allows us to look at IC 1101 not just as a monster, but as a monument. It is a monument to the forces that shaped the early universe. It is a fossil that preserves the history of the cosmic web. When we look at its golden light, we are looking at the combined output of stars that were born in 100 different places, stars that have been brought together by the relentless pull of gravity to share a common fate. It is a melting pot of the cosmos. The atoms in the atmosphere of a planet in IC 1101 might have come from a dozen different ancestral galaxies. The metal in the ground might have been forged in supernovae that exploded millions of light years apart. It is a place of convergence, and this convergence speaks to us about our own place in the universe. We, too, are the products of convergence. The atoms in our bodies are not native to the Earth. They were forged in stars that died long before the solar system existed. We are made of cosmic debris. We are the survivors of a violence we cannot remember. The iron in your blood is a relic of a supernova. The gold in your ring is a relic of a neutron star collision. We carry the scars of the universe in our very chemistry. IC 1101 is just the same story writ large. It is the same process of destruction and rebirth, magnified to a scale that breaks our imagination. As we contemplate the violence of this galaxy's history, we must also confront the dark side of its structure, not the black hole, but the invisible skeleton that holds it all together. We have spoken of the 100 trillion stars, the visible matter. But if you were to put IC 1101 on a cosmic scale, the stars would account for only a tiny fraction of its weight. The vast majority of the galaxy is made of dark matter. This mysterious substance, which does not emit light, does not reflect light, and does not block light, is the true ruler of the galaxy. It forms a massive halo, a sphere of invisible influence that extends far beyond the visible stars. Scientists estimate that the total mass of the galaxy, including this dark halo, is over 1,000 trillion suns. Imagine looking at a foam floating on the ocean. The foam is white and visible, bubbly and complex, but it is just a thin layer on top of the deep, dark water. The stars of IC 1101 are the foam. The dark matter is the ocean. The stars are just the decoration, the fairy lights strung up on the invisible structure. Without the dark matter, the galaxy would fly apart. The stars are moving too fast to be held by their own gravity. They are orbiting in a deep gravitational bowl created by the dark matter. We are looking at a ghost and seeing only the clothes it is wearing. The true galaxy, the massive object that warps space and bends time, is invisible to us. We can only map it by watching how the stars move, like watching leaves swirling in the wind to see the invisible air. This adds a layer of spectral terror to the giant. It is not just a monster of light. It is a monster of the dark. It is an iceberg, where 90% of the mass is hidden from our senses. We are observing the tip of the spear. The dark matter halo of IC 1101 is one of the largest concentrations of mass in the universe. It is a gravitational lens, a magnifying glass that bends the light of galaxies behind it. When astronomers look at the cluster, they see the background galaxies distorted into arcs and rings by the sheer weight of the dark matter. It is a presence that cannot be ignored, a silent, heavy God that dictates the motion of everything around it. So, When we try to visualize IC 1101, we must see it in dual layers. There is the layer of light, the golden mist of old stars, the scoured core, the remnants of the mergers. And there is the layer of darkness, the vast invisible halo that creates the gravitational well. The violence of the mergers was not just a collision of stars. It was a collision of dark matter halos. It was the merging of great invisible clouds that rippled and sloshed and settled into a new shape, dragging the visible stars along with them. The history of the universe is largely a history of dark matter doing things in the dark, with the stars merely serving as glowing tracers of the action. This realization is humbling. It reminds us that our senses are limited. We evolved to see light because we live near a star, but the universe is mostly dark. We are creatures of the foam, trying to understand the ocean, and IC 1101, in all its terrifying scale, is the perfect teacher. It shows us the violence that creates order. It shows us the invisibility of the true reality. It shows us that what we see is not what is. The peaceful night sky is a mask. The solid galaxy is a fluid in slow motion. The visible stars are just the tip of the iceberg. As we end this chapter of our journey, let the image of the gravitational dance stay with you. Picture the black holes spiraling in the dark. Picture the stars being flung out like sparks from a wheel. Picture the invisible halo holding it all in its crushing grip. And feel the vertigo of knowing that this violent, invisible, massive reality is the true face of the cosmos. It is not a place of human peace. It is a place of physical law, operating with a cold, terrifying, and majestic indifference. And yet, out of this indifference, out of this violence, comes the stability that allows for stars, for planets, and perhaps for minds that can wonder. We are the children of the storm, finding quiet in the eye of the hurricane. When we gaze up at the night sky from the safety of our terrestrial gardens, we are accustomed to thinking of space as a cold place. We have been taught that the void between the stars is a vacuum, a place of absolute zero, where life freezes in an instant and where silence reigns supreme. And in the vast, lonely stretches between the galaxies, in those great cosmic voids we explored earlier, this is largely true. But nature loves to defy our expectations, and in the dense, crowded neighborhoods of the universe, like the Abel 2029 cluster where our giant IC 1101 resides, the rules of temperature are turned upside down. If you were to strip away the stars of this cluster, if you were to erase the 100 trillion suns of the central galaxy and the thousands of other galaxies that orbit it, you would not be left with an empty darkness. You would be left with a ghost. You would see a vast glowing atmosphere of gas that permeates the entire cluster, a fog of baryonic matter that outweighs all the stars combined. And this gas is not cold. It is hot. It is unimaginable, terrifyingly hot. It burns at temperatures of tens of millions of degrees, glowing fiercely in X-ray light, a testament to the violence of the cluster's formation and the invisible energy that courses through its veins. This hot gas is known to astronomers as the intracluster medium. It is the blood of the galaxy cluster, a thin, tenuous plasma that fills the space between the galaxies. On a human scale, it is incredibly sparse. If you were to scoop up a cubic meter of this gas, you would find only a few atoms inside. It is a vacuum far more perfect than anything we can create in our best laboratories on Earth. Yet, because the cluster is so enormous, spanning millions of light years across, this sparse gas adds up to a staggering amount of mass. In fact, in a typical galaxy cluster, there is 5 times more mass in this hot gas than there is in all the stars and galaxies put together. When we look at IC 1101 in visible light, we are seeing only the tip of the iceberg. We are seeing the jewels, but missing the crown. The true body of the cluster is this superheated atmosphere, a reservoir of primordial material that has been trapped in the gravitational well of the dark matter halo for billions of years. But why is it so hot? How can empty space burn with the heat of a stellar core? The answer lies in the relentless pull of gravity. As the cluster formed over eons, as primordial gas clouds fell toward the center of the dark matter web, they gained speed. They fell for millions of light years, accelerating under the crushing gravity of the cluster. When these gas streams collided, when they slammed into the denser material already at the center, their kinetic energy, the energy of their motion, was converted into thermal energy, the energy of heat. It is the same principle that makes a meteor glow when it hits Earth's atmosphere, but on a cosmic scale. The gas of the intracluster medium is the thermal scar of the cluster's birth. It is the friction of the universe folding in on itself. And because the gas is so thin, it cannot easily cool down. It is trapped in a state of eternal fever, radiating its energy away as X-rays, but unable to shed enough heat to collapse and form new stars. This brings us to the central tragedy of IC 1101, a paradox that explains why this monster is a dead galaxy, despite sitting in a sea of fuel. You see, galaxies need cold gas to form stars. Stars are born when clouds of hydrogen cool down enough to clump together under their own gravity. Hot gas moves too fast. The atoms are buzzing with too much energy to settle down and collapse. So, for a galaxy to remain alive, for it to keep birthing new suns, it needs a supply of cold gas. In the Able 2029 cluster, there is a natural process called a cooling flow. In theory, the hot gas near the center of the cluster, where it is densest, should be radiating away its energy. As it cools, it should rain down onto the central galaxy, IC 1101. This rain of cooling gas should be enormous, delivering hundreds of solar masses of fresh fuel every single year. If this were happening unchecked, IC 1101 would not be a red and dead giant. It would be blazing with blue fire. It would be a starburst galaxy, converting that cooling rain into billions of new stars, renewing itself in a frenzy of creation. But when we look at IC 1101, we do not see this frenzy. We see an old, quiet, red galaxy. The cooling flow has been stopped. The rain has been arrested. Something is keeping the gas hot. Something is fighting against the natural tendency of the universe to cool down. That something is the monster in the basement. It is the supermassive black hole at the heart of the galaxy. This brings us to one of the most fascinating concepts in modern astrophysics: feedback. The galaxy and its black hole are locked in a delicate self-regulating dance. When the gas in the cluster starts to cool and fall toward the center, it eventually reaches the accretion disk of the black hole. The black hole feeds. And as we discussed, when a black hole feeds, it is messy. It blasts out jets of particles and radiation at nearly the speed of light. These jets slam into the surrounding intracluster gas. They carry a tremendous amount of kinetic energy. Imagine a pot of soup on a stove. If you turn off the heat, the soup cools down. But if you have a mechanism that turns the burner back on every time the temperature drops, the soup stays hot forever. The black hole is the burner. The jets inject energy into the intracluster medium, creating shock waves that reheat the gas. They blow bubbles, vast cavities in the hot atmosphere that we can see with our X-ray telescopes. These cavities are enormous. Some are millions of light years across. They are the physical evidence of the black hole's power, fossils of past eruptions that pushed the gas away and kept it from cooling. This is the thermostat effect. If the gas cools too much, it feeds the black hole. The black hole wakes up, blasts the gas with energy, and heats it back up. The feeding stops. The black hole goes back to sleep. The gas starts to cool again. The cycle repeats. For billions of years, this heartbeat has kept IC 1101 in a state of suspended animation. It is starving in the midst of a banquet, unable to eat the food that surrounds it because its own heart beats too hot. There is a profound philosophical resonance in this mechanism. It speaks to the balance of nature, even at the largest scales. The universe is not a runaway train. It has checks and balances. The growth of the galaxy is limited by the growth of the black hole. The creation of order, stars, is limited by the chaotic release of energy, jets. We see this pattern everywhere, from the regulation of animal populations in an ecosystem to the regulation of temperature in the human body. Homeostasis is not just a biological concept. It is a cosmic one. IC 1101 is a system in homeostasis, caught in a gravitational trap where it can neither grow nor die, suspended in a warm, X-ray glowing amber. It is a perfect, stagnant equilibrium. But let us go deeper into the visual of these bubbles. Astronomers studying the Abel clusters have found ripples in the hot gas, like sound waves moving through air. These are sound waves, in a sense, pressure waves created by the periodic outbursts of the black hole. The note they sing is a B-flat, but it is a B-flat 57 octaves below middle C. It is a sound so deep that it would take 1 billion years to hear a single vibration. This is the song of the black hole. It is singing to its galaxy, and the energy of that song is what keeps the gas hot. The universe is filled with music, with vibrations and resonances that shape the structure of matter. We are just deaf to the frequency. But the gas hears it. The stars hear it. The structure of the galaxy is sculpted by this invisible symphony of gravity and pressure. Now, imagine you are an observer floating in this hot, thin atmosphere, millions of light years away from the central galaxy. You would be bathed in X-rays, invisible to your eyes, but deadly to your biology. To your naked eye, the space around you would look dark, but if you could see in X-rays, the entire sky would be glowing with a diffuse, milky luminescence. You would see the great filaments of the cosmic web connecting to the cluster, channeling fresh gas and dark matter into this gravitational reservoir. You would see the galaxies of the cluster floating in this glowing fog like ships at sea. And in the center, you would see the giant IC 1101, anchored like a great island. You might see the faint, ghostly flicker of the radio jets shooting out from the core, pushing against the hot gas, inflating those invisible bubbles. You would be witnessing the metabolism of the universe. This hot atmosphere does more than just regulate star formation. It also strips the galaxies that move through it. As smaller galaxies orbit within the cluster, they have to plow through this intracluster medium. It acts like a wind. If a spiral galaxy falls into the cluster, the wind of the hot gas can strip away its own internal gas supply. This process, called ram pressure stripping, is another form of galactic violence. It turns blue, living spiral galaxies into red, dead ellipticals. It is as if the cluster itself is a sterilizing environment, a place where the chaotic individuality of spiral galaxies is erased, replaced by the uniform conformity of the red and dead. IC 1101 sits at the center of this sterilization machine, the ultimate beneficiary of the process. It is the graveyard keeper, watching over a flock of dead galaxies, bathed in the preserving fluid of the hot plasma. The presence of this gas also tells us about the composition of the universe. The fact that most of the ordinary matter is out here in the gas rather than in the stars is a crucial clue for cosmologists. It matches the predictions of the Big Bang Theory about how much hydrogen and helium should have been produced in the first few minutes. The Abel 2029 cluster is a laboratory that confirms our understanding of the origin of everything. The atoms in that hot gas are the pristine leftovers of creation, never processed through a star, never fused into heavy elements. They are the original stuff of the cosmos, suspended in time, waiting for a future that may never come. And what of that future? The delicate balance between the cooling gas and the heating black hole cannot last forever, though it is incredibly stable. Eventually, on timescales of trillions of years, the black hole will run out of fuel to power its jets, or the gas will finally cool, despite the heating. But there is a greater force at work, the expansion of the universe. As we discussed, dark energy is pushing the universe apart, but inside the cluster, gravity is strong enough to hold everything together. The Abel 2029 cluster will remain a bound object even as the rest of the universe disappears over the horizon. It will become an island universe in the truest sense. The hot gas will remain trapped. The galaxies will eventually merge into one. IC 1101 will grow to consume its entire cluster. It will become a single, hypergalactic object, a ball of stars and dark matter and hot gas drifting alone in an infinite void. There is a specific kind of loneliness in this realization. We often think of space as lonely because of the distances, but the true loneliness is the isolation of causality. Once the other clusters disappear beyond the cosmic horizon, no light, no information, no gravity can ever reach us from them. We will be cut off. IC 1101 is destined to be the lonely king of a shrinking kingdom. The hot gas that surrounds it is like the walls of a fortress, keeping the galaxy safe, but also imprisoning it. The feedback loop that regulates it is a cycle of survival, but it is also a cycle of stagnation. It reminds us that stability comes at a cost. The cost is change. The cost is new life. To be perfectly stable is to be perfectly dead. Yet, in that hot, glowing fog, there is energy. Immense, untapped energy. If a civilization could harness the heat of the intracluster medium, if they could tap into the temperature difference between the hot gas and the cold black hole, they would have a power source that could last for eons. Perhaps the ancient civilizations of IC 1101, those watchers of the red skies we imagined, have moved off their planets. Perhaps they live in great habitats floating in the halo, warming themselves by the glow of the X-ray gas, listening to the B-flat hum of the black hole. Perhaps they have become creatures of the medium, abandoning the rock and stone for the fluid and the flow. In a universe this big, with energy this abundant, life might find ways to exist that we cannot even conceive. As we float here, suspended in the imagination of this hot, invisible ocean, let us feel the vertigo of the temperature, millions of degrees. In the emptiness of space, it defies common sense. It challenges our intuition. But it is the truth. The universe is not just a collection of cold rocks and burning stars. It is a complex, dynamic, breathing system of gas and gravity regulated by feedback loops of terrifying power. The dead galaxy is alive with physics. The empty space is heavy with matter. The silence is full of song. We are just beginning to learn how to listen. Sleep now with the knowledge that the universe has a heartbeat. It has a thermostat. It looks after itself with a precision that borders on the miraculous. You are part of a system that knows how to maintain its balance, from the smallest cell in your body to the largest cluster in the cosmos. The heat of the intracluster medium is just another blanket in the dark, another layer of protection in the vast, cold night. You are safe within the machinery of the stars. We live our lives under the comforting illusion of permanence, believing that the sun will always rise in the east, that the constellations will always hang in their familiar places, and that the universe is a static stage upon which the drama of existence plays out forever. We build our civilizations on stone and steel. We carve our names into monuments, and we write our histories as if we expect there to be an audience to read them for eternity. But if there is one terrifying truth that astronomy forces us to confront, one realization that shatters our sense of security more than any other, it is that the universe is not static. It is not permanent. It is a story with a beginning, a middle, and an inevitable end. And we, the children of the stars, are living in a very specific, very fleeting chapter of that story. We are living in the era of starlight. It is a golden age, a brief, glorious period of cosmic history where matter has organized itself into burning spheres of plasma that flood the void with energy. But this era is not infinite. It is a finite resource. And nowhere is the mortality of light more evident, more visceral, and more haunting than in the colossal dying body of IC1101. To understand the tragedy and the majesty of this giant galaxy, we must look at the history of star formation itself. Astronomers have reconstructed the timeline of the universe's fertility, plotting the rate at which new stars are born against the age of the cosmos. What they have found is a curve that rises steeply in the early universe, peaking about 3 to 4 billion years after the Big Bang, in an epoch known as cosmic noon. During this time, the universe was a fireworks factory. Galaxies were colliding, gas was collapsing, and stars were being born at a rate 10 times higher than today. The sky was ablaze with the blue-white fire of newborn giants. But since that peak, the rate of star formation has been plummeting. The universe is running out of gas. It is running out of the raw material needed to make new suns. The party is winding down. The lights are being turned off one by one. And IC1101 is a galaxy that left the party early. It is a galaxy that consumed its fuel in a gluttonous frenzy billions of years ago, growing fat and massive, but leaving itself with nothing for the future. When we look at IC1101 through our telescopes, we are looking at a cosmic retirement home. We are looking at a population of stars that are all aging together with no new generation to replace them. In a vibrant spiral galaxy like the Milky Way, we see the cycle of life in action. We see the dark nebulae where stars are being born, the bright blue clusters of adolescence, the yellow middle-aged stars like our sun, and the expanding shells of dying stars. It is a garden in full bloom, with seedlings and ancient trees growing side by side. But IC1101 is a monoculture. The seedlings are gone. The blue giants, those massive stars that live fast and die young, exploded billions of years ago. They are long gone, leaving behind only neutron stars and black holes as their tombstones. What remains are the survivors, the stars that burn slowly enough to endure the eons. This brings us to the red and dead classification. It sounds harsh, a label of cosmic failure, but in reality, it is a description of a profound change in the nature of light. The stars that dominate IC1101 today are the K-type and M-type stars, the orange and red dwarfs. These are stars with a fraction of the mass of our Sun. Because they are small, the pressure in their cores is lower, and they fuse hydrogen into helium at a glacial pace. A star like our Sun will burn for about 10 billion years. A red dwarf can burn for 10 trillion years. That is 1,000 times longer than the current age of the universe. These tiny, dim stars are the keepers of the flame. They are the ones that will carry the memory of the light into the deep, dark future. In IC 1101, there are trillions of them, a vast, silent army of embers glowing in the dark. Imagine standing on a planet orbiting one of these red dwarfs in the outskirts of IC 1101. Your sun would not be a blinding yellow disk, but a large, dull red ember hanging in the sky. It would provide heat, yes, but the light would be different, softer, shifting toward the infrared. Plants on such a world, if they existed, would not be green. They might be black or deep purple, evolved to absorb the weak energy of their dying star. And looking up at the galactic sky, you would not see the brilliant, piercing jewels of Orion or the Pleiades. You would see a haze of other red stars, a sky filled with thousands of dying coals. It would be a world of eternal autumn, a world where the spring of the universe is a distant, mythical memory. But even these long-lived stars are not immortal. The terrifying truth of the second law of thermodynamics is that entropy always increases. Disorder always grows. Energy flows from hot to cold, and once it is spread out, it cannot be gathered back together. Every photon of light that leaves a star is energy lost forever to the void. Every atom of hydrogen fused into helium is fuel that can never be used again. The universe is a machine that is slowly winding down. IC 1101 is just further along in this process than we are. It is a preview of our own ultimate fate. Eventually, the Milky Way will merge with Andromeda. Our gas will be used up or stripped away, and we too will become a red and dead elliptical galaxy, a smooth blob of aging stars drifting into the dark. Let us walk through the timeline of this slow death, because the scales involved are mind-bending. Over the next few billion years, the sun-like stars in IC 1101, the G-type stars that might host life as we know it, will begin to die. They will swell up into red giants, swallowing their inner planets, boiling away any oceans, and scorching any biospheres. Then they will shed their outer layers, creating beautiful planetary nebulae, brief flashes of color that will bloom like flowers in the galactic graveyard. Finally, they will collapse into white dwarfs, tiny objects the size of Earth, but with the mass of a sun. These white dwarfs are not burning anything. They are just hot balls of carbon and oxygen slowly cooling down like iron removed from a forge. They will glow for billions of years, but eventually they too will fade to black. Then only the red dwarfs will remain. For trillions of years, IC 1101 will be illuminated only by these faint red lanterns. It will be a dim, shadowy place. Life might still cling to worlds orbiting these stars, huddling close for warmth, civilizations that have forgotten the concept of a bright sky. But one by one, even the red dwarfs will run out of fuel. They will not explode. They do not have enough mass for that grandeur. They will simply fizzle out, shrinking into white dwarfs composed of helium. The lights will go out. One by one, the 100 trillion stars of IC 1101 will wink out of existence. The galaxy will become dark. What happens then? What happens when the last star dies? This is the beginning of the degenerate era of the cosmos. IC 1101 will still be there. Its gravity will still hold it together, but it will be a galaxy of corpses. It will be a swarm of cold white dwarfs, neutron stars and black holes orbiting in the absolute dark. Occasionally, two of these remnants might collide, creating a brief flash of light, a supernova or a gamma-ray burst that illuminates the dead galaxy for a few weeks before fading back into the silence. But, for the most part, it will be a graveyard, a place of ghosts. The biggest galaxy will become the biggest tomb in the universe, a monument to the era of starlight that has passed into history. This vision of the future is melancholy, yes. It fills us with a sense of loss. We want the universe to be eternal. We want the stars to shine forever, but there is a profound beauty in this impermanence. The fact that the stars are dying makes them precious. The fact that we are living in the brief, golden window of time when the universe is hospitable to life makes our existence a miracle of timing. We are the lucky ones. We are the ones who get to see the glory. We get to see the spiral arms, the blue giants, the star-forming nebulae. We get to see the universe at its most vibrant, its most creative, its most alive. If you were a being born in the Degenerate era, 100 trillion years from now, looking at the dark sky of IC 1101, you would look at the ancient records of the stelliferous era, the era of stars, with a sense of mythical wonder. You would read about a time when the sky was full of light, when energy was free, when the universe was warm. You would look back at us at this moment as the mythical golden age of the cosmos. We are the ancients. We are the ones living in the time of legends. And there is another layer to this story. As the stars of IC 1101 die, they do something remarkable. They enrich the galaxy. We spoke earlier of how the first stars forged the heavy elements. The dying stars of IC 1101 continue this process. The red giants create carbon and nitrogen. The merging neutron stars create gold and platinum. The white dwarfs, when they steal matter from a neighbor and explode as type Ia supernovae, create iron. Even in its death throes, the galaxy is becoming chemically more complex. The dust that floats between the dead stars is rich with the building blocks of life. It is a sterile richness, perhaps, because there are no new stars to warm it, but it is there. The potential is there. Now, consider the supermassive black hole again. In this dark future, it will be the last source of energy. As the dead stars orbit the center, their orbits will slowly decay due to the emission of gravitational waves. Over eons, they will spiral inward. The black hole will feed on the corpses of its children. Every time a white dwarf or a neutron star falls in, there will be a flare of radiation. The quasar might wake up again, briefly, illuminating the dark galaxy with a beacon of light. These will be the last gasps of IC 1101, the final heartbeats of the giant, before it settles into the eternal sleep of the heat death. There is a concept in Japanese philosophy called mono no aware, the pathos of things. It is a sensitivity to ephemera, a bittersweet appreciation of the transience of nature. It is the feeling you get when you watch cherry blossoms fall, knowing they are beautiful precisely because they do not last. IC 1101 is the ultimate cosmic expression of mono no aware. It is a cherry blossom on the scale of 1 billion light years. It is vast, it is ancient, and it is fading. To study it is to practice the art of letting go. It is to accept that everything, even the largest structures in existence, is temporary. But let us not surrender to despair, because in this realization of mortality, there is a call to action. If the universe is dying, if the lights are going out, then it is our duty to witness it while it shines. It is our duty to be the eyes of the cosmos, consciousness, is the universe's way of remembering itself. By looking at IC 1101, by measuring its size, by counting its stars, by understanding its history, we are saving it from oblivion. We are encoding its existence into the realm of thought, into the realm of knowledge. As long as we remember it, as long as we tell its story, it is not truly dead. Think of the photon that hit the sensor of the telescope to create the image of IC 1101. That photon traveled for 1 billion years. It dodged galaxies. It survived the expansion of the voids. It ended its journey in the eye of a human being, or the lens of a human machine. That moment of contact is a sacred transaction. The universe spent 1 billion years delivering a message, and we were there to receive it. We were there to say, I see you. In a dying universe, the act of seeing is an act of defiance. It is an act of love. So, tonight, as you rest, think of the red dwarfs of IC 1101. Think of those trillions of dim, enduring stars keeping their vigil in the dark. They are the embers of the great fire of creation. They are the last watchmen. And you, with your short, bright human life, are like a spark leaping from the fire. You will not last as long as a red dwarf. You will not see the end of the universe. But you burn brighter. You have a mind. You have a heart. You can feel the vertigo of the infinite. And in that feeling, you transcend time. You touch the eternal. The story of the universe is not a tragedy. It is a cycle. And even after the stars are gone, even after IC 1101 has faded into the dark, the laws of physics will remain. The potential will remain. Who knows what strange new forms of existence might arise in the blackness of the far future? Who knows what thoughts a black hole might think? The mystery does not end with the light. The mystery is infinite. There is a ghost in the machine of the universe, a phantom force that is silently, relentlessly, and invisibly rewriting the destiny of every star and galaxy in existence. For most of human history, and indeed for most of the 20th century, astronomers believed that the ultimate fate of the cosmos was a simple binary choice determined by gravity. We looked at the stars, we looked at the galaxies, and we saw that they all had mass. We knew that gravity is an attractive force, a cosmic glue that pulls everything together. Therefore, logic dictated that the expansion of the universe, which began with the violence of the Big Bang, must be slowing down. It must be acting like a ball thrown into the air. Rising, yes, but fighting against the pull of the earth. Slowing, until eventually it stops. The question was simply whether there was enough mass to reverse the expansion entirely, leading to a big crunch where everything falls back together, or if the universe would just coast forever, expanding at an ever slower rate. It was a comforting, mechanical view of the world. It suggested that gravity was the master. But in 1998, two teams of astronomers observing distant supernovae made a discovery that shattered this logic and plunged us into a new era of existential uncertainty. They found that the universe is not slowing down. It is not coasting. It is speeding up. The ball thrown into the air is not falling back down. It is rocketing upward faster and faster, as if seized by an invisible hand. This invisible hand is what we call dark energy. It is perhaps the most unsettling concept in all of science because it suggests that the majority of the universe, about 68% of the total energy density, is made of something we cannot see, cannot touch, and do not understand. All the stars, all the planets, all the gas, all the people, and even all the dark matter we discussed earlier, That is just the minority report. The true ruler of the cosmos is this mysterious energy of empty space. And unlike gravity, which pulls things together, dark energy pushes things apart. It is a kind of anti-gravity, a repulsive force that is inherent to the fabric of space itself. As the universe expands, it creates more space. And because dark energy is a property of space, more space means more repulsive energy. This creates a runaway feedback loop. The more the universe expands, the harder dark energy pushes. The harder it pushes, the faster it expands. It is a terrifying exponential curve that is driving the galaxies apart with a violence that will eventually tear the cosmic web to shreds. Now, let us bring this terrifying realization back to our giant IC 1101. We have described it as a monster that sits at the center of the Able 2029 cluster, a king on a throne of gravity. For now, the gravity of the cluster is strong enough to resist the push of dark energy. The thousands of galaxies in the cluster are bound to IC 1101 by an invisible chain that is stronger than the expansion of space. They are safe for the moment. They will continue to dance, to merge, to feed the central giant. But beyond the edges of the cluster, the war is already lost. The other galaxy clusters, the other great islands of the universe, are being carried away from IC 1101 by the swelling tide of dark energy. They are receding faster and faster. Imagine you are an astronomer living in IC 1101 billions of years from now. You point your telescope at a distant cluster of galaxies, a neighbor that your ancestors might have catalogued. But as you watch, its light becomes redder and redder, stretched by the expansion of space, until it fades into the infrared, then into radio waves, and then nothing. It vanishes. The galaxy has crossed the cosmic event horizon. This is the point of no return. The space between IC 1101 and that distant galaxy is expanding faster than the speed of light. The light emitted by that galaxy can no longer reach you. It is trying to swim upstream against a current that is moving faster than it can swim. The galaxy has not been destroyed. It is still there, evolving, shining, living. But it has been severed from your reality. It has fallen off the edge of the observable universe. This is the isolation that awaits us all. As the eons pass, the cosmic horizon will shrink. One by one, the distant galaxy clusters will disappear from the sky of IC 1101. The observable universe, which today is filled with 2 trillion galaxies, will become empty. The sky will go dark. Eventually, the only thing visible to an observer in IC 1101 will be the stars of its own cluster. The rest of the cosmos will have been erased. It will be as if the universe has shrunk down to a single island, surrounded by an infinite, impenetrable ocean of nothingness. This leads to a profound and melancholy thought experiment. Imagine a civilization that evolves in IC 1101 100 billion years from now. By then, the other galaxies will have vanished. Their astronomers will build telescopes and look up, but they will see only the black void. They will have no evidence of the Big Bang, for the cosmic microwave background will have faded to invisibility. They will have no evidence of the expansion of the universe, for there will be no distant galaxies to measure moving away. They will have no concept of a cosmos vast in time and space. They will likely conclude that their galaxy cluster is the entire universe, static, eternal, and alone. They will construct a model of reality that is logical, self-consistent, and completely wrong. They will be trapped in a cosmic illusion, isolated by the accelerating expansion. We, living in this privileged moment, are the only ones who can see the truth. We are the witnesses to the diversity of the cosmos before it flies apart. We are the keepers of the history that will one day be impossible to read. But let us return to the cluster itself, to the Able 2029 system. While the rest of the universe disappears, gravity will tighten its grip on the local neighborhood. The galaxies that are currently orbiting IC 1101 are doomed to a different fate. They are not flying apart. They are falling in. Over the next few billion years, the friction of the intracluster medium and the gravitational drag of the dark matter halo will cause their orbits to decay. One by one, the spirals in the dwarfs will spiral down into the center. They will be ripped apart by tidal forces, their stars streaming like ribbons into the body of the giant. IC 1101 will consume its children. It will grow even larger, absorbing the mass of its entire cluster. This future isolation changes the emotional resonance of the galaxy. We started this journey by calling it a monster, a terrifying giant. But seen through the lens of deep time, it becomes a tragic figure. It is the last man standing. It is a survivor that has outlived its family, its neighbors, and eventually its connection to the rest of reality. It is destined for a solitude so absolute that we lack the language to describe it. To be alone in a room is one thing. To be alone in a galaxy is another. But to be a galaxy that is alone in the universe, that is a level of existential loneliness that chills the bone. And yet, within that lonely island, life could still persist. The red dwarfs we spoke of earlier will still be burning. The planets will still be orbiting. The civilizations of the future, trapped in their island universe, will still have trillions of years to explore their home. They might not know about the other galaxies, but they will know about their own vast domain. They will map the interior of the giant. They will harness the energy of the black hole. They might even find a kind of peace in their isolation. Without the distraction of the external cosmos, they might turn inward. They might master the physics of their own reality, to a degree we can only dream of. The force of dark energy also raises a terrifying question about the ultimate fate of matter itself. There is a hypothesis known as the Big Rip. If dark energy continues to strengthen over time, if the acceleration continues to increase without limit, then eventually it will overcome not just the gravity between galaxies, but the gravity within galaxies. It will tear the clusters apart. Then it will tear the galaxies apart. Then it will tear solar systems apart. Finally, in the last fraction of a second, it will overcome the electromagnetic and nuclear forces, tearing atoms themselves apart. The universe would end in a singularity of total shredding, where every particle is isolated from every other particle. Most scientists today do not believe the Big Rip is the most likely scenario. They favor the Big Freeze, where the universe simply expands and cools forever. But the possibility hangs there, a ghost in the equations. It reminds us that our existence depends on a delicate balance of forces. We are here because gravity is strong enough to hold us together, but not so strong that it crushed us immediately. We are here because dark energy is weak enough to allow galaxies to form, but strong enough to prevent a big crunch. We are walking a tightrope between the crushing dark and the ripping dark. IC 1101, with its immense mass, is the most resilient object in the universe against this tearing force. Its gravity is so intense that it will hold together longer than almost anything else. If the Big Rip does happen, IC 1101 will be the last fortress to fall. It will be the final stronghold of matter against the dissolving acid of the expanding void. The stars in its core, packed tightly together in the gravitational grip of the black hole and the dark matter halo, will be the last lights to be extinguished. It is the ultimate bunker. There is a strange irony in this. The forces that make the universe terrifying, the crushing gravity, the devouring black holes, the isolating expansion, are also the forces that create the pockets of safety where we can exist. We fear the dark, but the dark energy is what prevents the universe from collapsing on itself. We fear the black hole, but the black hole regulates the galaxy. We fear the size of IC 1101, but its size is what makes it a sanctuary in the deep future. The terror and the safety are two sides of the same coin. As you lie in the dark, think about this expansion. Feel the space in your room. It seems static, unchanging. But on the largest scales, space is stretching. The distance between the Milky Way and the distant quasars is growing by millions of miles every second. You're riding on the surface of an expanding balloon. The universe is getting bigger, emptier, and colder with every breath you take. It is a process that cannot be stopped. It is the fundamental nature of our reality. But do not let this make you feel small in a negative way. Let it make you feel precious. The fact that matter has come together to form you, to form the earth, to form the stars, is a victory against the expansion. You are a knot of complexity in a universe that wants to smooth everything out. You are a defiance of the void, and IC 1101 is the greatest defiance of all. It is a stubborn, massive refusal to be dispersed. It is a castle built of 100 trillion stones standing against the tide of nothingness. The story of the universe is a story of the battle between gravity and dark energy. Gravity wants to pull things together. Dark energy wants to push them apart. Gravity builds. Dark energy isolates. Gravity creates the heat of stars. Dark energy creates the cold of the void. In IC 1101, gravity has won a great victory. It has built a structure so massive that it will endure for eons. But in the end, dark energy plays the long game. It has time on its side. It has the infinite future. This realization that we are living in a temporary victory makes the present moment sparkle with urgency. We cannot take the universe for granted. We cannot assume that the stars will always be there to guide us. We have to appreciate them now. We have to learn from them now. We have to drink in the light of the galaxies while we can still see them. Because a time is coming in the deep, dark future when the sky will be empty. A time when the inhabitants of the cosmos will look up and see nothing but the black. We are the lucky ones. We are the ones with the view. So, when you think of IC 1101, do not just see it as a distant object. See it as a fellow traveler. See it as a companion in the fight against the dark. It is fighting the same battle you are. The battle to exist, to hold together, to be something rather than nothing. It is doing it on a scale of millions of light years, and you are doing it on a scale of 6 feet. But the struggle is the same. We are all islands of order in a sea of chaos. We are all holding on against the expansion, and for now, we are winning. The stars are still shining. The galaxy is still turning. The universe is still beautiful. And perhaps, in that shared struggle, there is a kind of connection that transcends the light years. We are not alone in the dark. We are part of a fleet of islands, sailing together through the expanding night. We may be drifting apart. We may be destined for isolation. But for this moment, for this glorious, brief, star-filled moment, we are together. We can see each other. And that is enough. Sleep well, traveler. The universe is expanding, but your place in it is secure. You are anchored by gravity, warmed by starlight, and connected by the deep, invisible web of existence. The dark energy can wait. Tonight, we rest in the light. At the very center of the cosmic web, anchored deep within the gravitational heart of the Abel 2029 cluster, lies a region of space where the laws of physics as we experience them begin to unravel, replaced by a reality so extreme that it defies the intuitive logic of the human mind. We have spoken of IC 1101 as a galaxy of 100 trillion stars, a glowing island of light that stretches for 6 million light years across the void. But every kingdom has a throne, and every hurricane has an eye. If we were to peel back the layers of stars like the skins of an onion, stripping away the golden halo of red dwarfs and the scoured shell of the core, we would find ourselves staring into the face of a monster that makes the rest of the galaxy look like a mere decoration. We would find ourselves confronting one of the largest supermassive black holes ever discovered in the observable universe. It is an object of such terrifying mass and such profound darkness that it acts as the gravitational anchor for the entire cluster, a singularity that dictates the motion of trillions of suns. Tonight, we must journey into the dark heart of the giant, past the event horizon, to understand the ultimate destiny of matter and the strange, elastic nature of time itself. To grasp the scale of this black hole, we must first abandon our terrestrial sense of weight. The black hole at the center of our own Milky Way, Sagittarius A, is a formidable object containing the mass of 4 million suns. It is heavy enough to whip stars around it at millions of miles per hour, but the black hole at the center of IC 1101 is in a completely different category of existence. Astronomers estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. To put that into perspective, this single dark object has 25,000 times more mass than the black hole that anchors our entire galaxy. If you were to take every star in the large Magellanic Cloud and every star in the small Magellanic Cloud and crush them all together into a single point, you would still not have enough mass to equal this one monster. It is a hole in reality so deep that it bends the fabric of space and time almost to the breaking point. The physical size of this object is equally mind-bending. A black hole is defined by its event horizon, the spherical boundary beyond which nothing, not even light, can escape. The size of this horizon is directly related to the mass of the black hole. For a black hole of 50 billion solar masses, the event horizon would have a radius of roughly 150 billion kilometers. Numbers like this tend to wash over us without making an impact, so let us use a map we understand. The distance from the Earth to the Sun is about 150 million kilometers. The distance from the Sun to Pluto, at its farthest, is about 7 billion kilometers. The entire solar system, including the Kuiper belt of icy comets, is a tiny speck compared to this black hole. If you were to replace our Sun with a black hole of IC 1101, the event horizon would not just swallow the Earth, it would swallow Jupiter, Saturn, Uranus, Neptune, and Pluto. It would extend out into interstellar space, engulfing the Voyager probes and everything else we have ever launched. Our entire cosmic neighborhood, everything we consider home, would vanish inside the black hole without even touching the sides. It is a region of darkness 16 times larger than our solar system. But what would it be like to approach such a thing? As you drifted toward the center of IC 1101, the first thing you would notice is the distortion of light. The immense gravity of the black hole acts like a lens, bending the light of the stars behind it. You would see a ring of distorted starlight, an Einstein ring, circling a sphere of absolute blackness. This is the shadow of the black hole. It is a hole in the sky where no stars shine, a circle of nothingness that grows larger and larger as you approach. But the most terrifying effect would not be visual, it would be temporal. According to Einstein's theory of general relativity, gravity warps time. The stronger the gravity, the slower time moves. Near the event horizon of a supermassive black hole, this effect becomes extreme. Imagine you are watching a brave astronaut falling toward the black hole while you remain safely in a spaceship far away. As the astronaut gets closer to the horizon, you would see their movements slow down. They would appear to be moving in slow motion, like a film reel being hand-cranked at a dragging pace. The light coming from them would turn redder and dimmer, stretched by the gravity as it struggled to climb out of the well. Eventually, as they reached the edge of the event horizon, you would see them freeze. To your eyes, they would never cross the boundary. They would remain suspended there, a frozen, reddened ghost, fading slowly into invisibility over thousands of years. But from the astronaut's perspective, looking out at the universe, time would be speeding up. They would see the stars of the galaxy aging and dying in fast forward. They would see the future of the cosmos playing out in a blur of light. In a matter of minutes of their proper time, they would witness eons of cosmic history passing by. They would cross the horizon without even noticing a bump, falling toward the singularity at the center, leaving the universe behind forever. The interior of the black hole is a mystery that science has yet to fully solve. General relativity tells us that at the center, all that mass, 50 billion suns worth of matter, is crushed into a point of infinite density and zero volume called a singularity. At this point, space and time as we know them cease to exist. The laws of physics break down. It is a place where here and now lose their meaning. Some physicists suggest that the singularity might be a gateway to another universe, or a wormhole connecting to a distant part of our own. Others believe that quantum mechanics prevents the singularity from becoming truly infinite, creating a fuzzball of vibrating strings. But for anything falling in, the result is the same. The tidal forces near the singularity would become infinite. You would be stretched into a long, thin strand of atoms in a process physicists have vividly named spaghettification. Your biology, your chemistry, and eventually your atomic structure would be torn apart, added to the mass of the monster. However, the black hole at the center of IC 1101 is not currently eating. It is what we call a quiescent or dormant black hole. It has already consumed most of the gas and stars in its immediate vicinity. The scoured core we discussed earlier is the result of its past gluttony. It sits there in the dark, a silent giant, waiting for the occasional stray star to wander too close. When that happens, the star is ripped apart, creating a brief flare of light before the debris is swallowed. But for the most part, the black hole is quiet. It is a sleeping dragon, but even in its sleep, it dominates the galaxy. Its gravity holds the 100 trillion stars in their orbits. Its past outbursts have heated the intracluster gas, preventing new stars from forming. It is the reason the galaxy is red and dead. The black hole is the architect of the galaxy's sterility. There is a profound irony here. Black holes are often thought of as agents of destruction, and they are. But they are also agents of order. Without the supermassive black hole to anchor it, the galaxy might not have formed in the same way. Without the feedback from its jets, the galaxy might have burned through its fuel too quickly, becoming a chaotic mess rather than a stable giant. The black hole is the dark heart that regulates the pulse of the system. It is a symbiotic relationship between the light and the dark. The stars provide the mass. The black hole provides the center. They are locked in a dance that has lasted for 12 billion years. But what is the ultimate fate of this monster? Will it last forever? For a long time, physicists thought that black holes were eternal. Once matter fell in, it was gone for good. The black hole would just grow and grow, sitting there until the end of time. But in 1974, Stephen Hawking made a discovery that changed everything. He applied quantum mechanics to the event horizon and found that black holes are not truly black. They glow. They emit a faint radiation, now known as Hawking radiation. This happens because of the strange nature of the vacuum of space. In quantum physics, empty space is filled with pairs of virtual particles, a particle and an antiparticle, that constantly pop into existence and then annihilate each other. Usually this happens so fast that we cannot detect it. But near the event horizon of a black hole, something different happens. Sometimes a pair of particles pops into existence right on the edge. One particle falls into the black hole, while the other escapes into space. The particle that falls in has negative energy relative to the outside universe, which subtracts a tiny amount of mass from the black hole. The particle that escapes becomes real radiation. Over time, this process causes the black hole to lose mass. It evaporates. It shrinks. This is an incredibly slow process. A black hole the size of our sun would take 10 to the power of 67 years to evaporate. That is a 1 followed by 67 zeros. But for the supermassive black hole in IC 1101, the time scale is even longer. Because it is so massive, it is incredibly cold, colder than the background radiation of the universe. Right now, it is actually absorbing more energy from the cosmic microwave background than it is emitting in Hawking radiation. It is still growing, not shrinking. But in the far, far future, as the universe expands and cools, the background radiation will drop below the temperature of the black hole. Then, the evaporation will begin. It will take a Google years, 10 to the power of 100 years, for a black hole of 50 billion solar masses to evaporate completely. A Google years is a span of time so vast that there are no metaphors to describe it. If you were to count every atom in the visible universe, you would only reach about 10 to the power of 80. The number of years it takes for the black hole to die is billions of trillions of times larger than the number of atoms in existence. During this unimaginable expanse of time, the black hole will slowly leak its energy back into the void. It will shrink millimeter by millimeter, millennium by millennium. The galaxy around it will have long since gone dark. The stars will have turned into cold white dwarfs and neutron stars. Many of them will have been ejected from the galaxy by gravitational interactions. Others will have spiraled into the black hole. The universe will be a dark, empty place, populated only by black holes and drifting particles. And in that final era, the black hole era, the monster of IC 1101 will be one of the last lights left. As it gets smaller, it will get hotter. In its final moments, after a Google years of silence, it will explode. It will release all its remaining mass in a blinding flash of gamma rays, a final firework at the end of time. And then it will be gone. There will be nothing left of IC 1101. No stars, no gas, no black hole. Just a thin mist of particles and radiation spreading out into an infinitely expanding, infinitely dark universe. This is the concept of heat death, or the big freeze. It is the ultimate triumph of entropy. Even the black holes, the most permanent seeming objects in nature, are temporary. They are just distinct shapes of energy that exist for a while and then dissolve. The universe washes away all structures eventually. This realization that even the greatest monsters die can feel bleak. It forces us to confront the transience of all things. If a black hole that lasts for a Google years is temporary, what does that make us? We are less than a flicker. We are a rounding error in the decimal points of cosmic time. But there is another way to look at it. The fact that we can understand this process, the fact that we can use mathematics to predict the death of a black hole 50 billion times the mass of the sun, is a triumph of the human spirit. We are creatures of the moment, yes, but our minds can touch eternity. We can look into the face of the monster and understand its mortality. And there is something poetic about the idea of hawking radiation. It means that information is never truly destroyed, only scrambled. The matter that fell into the black hole, the gas, the stars, the light, is eventually returned to the universe, particle by particle. It is a form of cosmic recycling. The black hole is not a tomb. It is a transformative engine. It takes the orderly structure of matter and breaks it down into pure heat, returning it to the vacuum from which it came. It completes the cycle of existence. As you lie in the dark tonight, imagine that great black sphere sitting at the center of the universe's largest galaxy. It is silent. It is waiting. It is bending time around it like a cloak. It is the keeper of the galaxy's secrets. And realize that the silence you feel in your own room is connected to that silence. The gravity that pulls you into your bed is the same force that feeds the monster. You are connected to the black hole by the invisible threads of physics. You are part of the same story. The black hole teaches us about limits, the limit of light speed, the limit of density, the limit of time. But it also teaches us about the boundless nature of curiosity. We have never been to IC 1101. We never will, but we know what lies at its heart. We have weighed the monster. We have clocked its heartbeat. In the face of the dark, we have lit a candle of understanding, and that candle shines brighter than the accretion disk of any quasar. So let the concept of the event horizon be a comfort, not a fear. It represents the boundary of what can be known, but also the invitation to explore what lies beyond. The universe is full of horizons, and for every one we cross, we find a new mystery waiting. The monster in the dark is just another mystery, another piece of the grand puzzle that we are slowly, patiently putting together. Sleep now, safe in the knowledge that even the monsters follow the rules, and that even the darkness is filled with the light of understanding. There is a question that has echoed through the corridors of the human mind since the moment we first developed the capacity to look up and wonder, a question that sits at the very heart of our relationship with the cosmos. It is a question that we have whispered in our prayers, shouted in our stories, and now coded into the radio signals we send out into the void. Are we alone? For most of our history, the answer was a matter of faith or fantasy. We populated the stars with gods and monsters, with angels and ancestors, because the idea of an empty universe was too lonely to bear. But today, standing before the staggering reality of a galaxy like IC 1101, the question shifts from a philosophical musing to a statistical confrontation. We are no longer asking if there is room for life. We are staring at a mansion with 100 trillion rooms and asking why the hallways seem so quiet. The sheer scale of this galaxy forces us to reconsider everything we think we know about the rarity of biology. It demands that we confront the terrifying possibility that the universe is teeming with eyes that are looking back at us, or, perhaps even more terrifying, that in all this vastness, we are the only ones who can see anything at all. To grapple with this, we must return to the numbers, those cold, hard integers that define the scope of the possible. Our own galaxy, the Milky Way, contains perhaps 400 billion stars. Based on the data from the Kepler Space Telescope and other planet-hunting missions, we now know that planets are not rare anomalies. They are the rule. Almost every star has at least one planet. A significant fraction of those stars have rocky worlds orbiting in the Goldilocks zone, the narrow band where temperatures allow for liquid water. If we apply even the most conservative estimates to the Milky Way, we come up with billions of potential Earths. Now, take that logic and apply it to the giant. IC 1101 has 100 trillion stars. That is 250 times the population of the Milky Way. If the same rules of planet formation apply there, and the laws of physics suggest they do, then we are looking at a galaxy that could harbor hundreds of trillions of planets. Let that number sink into your bones. Hundreds of trillions of worlds. Worlds of rock and ice, worlds of gas and diamond, worlds with thick atmospheres and worlds with none. The diversity of landscapes in such a galaxy would be infinite. There would be planets where it rains glass sideways in howling winds. There would be planets covered in global oceans deeper than the Earth's radius. There would be planets tidally locked to their stars, with one side forever baking in an eternal day, and the other frozen in an eternal night. And somewhere, in that endless catalogue of worlds, surely there are planets like ours. Planets with blue skies and liquid water. Planets where the chemistry of carbon has learned to make copies of itself. Even if life is a miracle that happens only once in a billion years in a galaxy like IC 1101, that miracle would have happened 100,000 times. But IC 1101 is not just big, it is old. And this is where the story gets truly interesting. The stars in this galaxy formed billions of years ago. The violent epoch of star birth is over. The planets that orbit these stars have had eons to evolve. On Earth, it took 4 billion years for single-celled slime to evolve into a creature that could build a radio telescope. In IC 1101, there are systems that are twice as old as the Earth. If life emerged there, it has had time not just to evolve, but to transcend. We often imagine aliens as beings like us, biological creatures in spaceships exploring the stars. But a civilization that is 1 billion years older than us would be as incomprehensible to us as we are to an amoeba. They might have long since abandoned biology. They might have merged with their machines, or uploaded their consciousness into the fabric of light itself. They might not be living on planets at all, but inside the event horizons of black holes, or in the vast computational clouds of the galactic halo. This brings us to the Fermi paradox, the great silence that haunts our search for extraterrestrial intelligence. If the universe is so big and life is so probable, where is everyone? Why haven't we heard their signals? Why haven't we seen their megastructures blocking the light of stars? When we look at IC 1101, the paradox becomes a scream. With 100 trillion stars, the galaxy should be buzzing with activity. We should see the waste heat of galactic empires. We should see stars being rearranged into Dyson spheres to harvest their energy. But we see nothing. We see only the smooth golden glow of the stars and the silent orbit of the gas. The galaxy appears natural, untouched, and wild. There are two ways to interpret this silence. The first is the rare earth hypothesis. It suggests that perhaps we have underestimated the difficulty of creating complex life. Maybe getting from a single cell to a complex animal is harder than we think. Maybe the universe is full of bacteria, but empty of minds. Perhaps the specific conditions of Earth, our large moon that stabilizes our tilt, our magnetic field that protects our atmosphere, our position in the galaxy, are a unique combination that has never been repeated. If this is true, then IC1101 might be a graveyard of potential. It might be a galaxy of 100 trillion dead worlds, or worlds covered in slime that never learned to think. In this view, we are the lottery winners of the cosmos. We are the lonely kings of consciousness. It is a heavy burden, this idea. It makes our survival infinitely precious. If we destroy ourselves, we might be extinguishing the only light in the universe. But there is another, more hopeful, and perhaps more sleepy interpretation. It is the idea that advanced civilizations simply grow quiet. When we think of advanced, we think of expansion. We think of conquering the galaxy, like the empires of our history books. But perhaps true advancement is not about going outward. It is about going inward. Perhaps a civilization that survives for 1 billion years learns that the physical universe is harsh and limited. They might retreat into virtual realities of their own design, universes of infinite possibility running on the energy of a quiet red dwarf. They might stop broadcasting radio waves because they have found a better way to communicate using neutrinos or gravitational waves or quantum entanglement. They might be there right now in the heart of IC 1101, billions of them, living lives of unimaginable richness, but leaving no footprint that our primitive telescopes can see. They might be like the monks in a silent monastery, their presence defined by their stillness, not their noise. Imagine for a moment that you are one of these beings. You live on a world orbiting a red dwarf star deep in the core of the galaxy. Your sun is a constant, gentle presence in the sky, never setting, just dimming slightly as flares dance across its surface. Your civilization has existed for so long that you have forgotten your origins in the primordial soup. You have solved the problems of energy, of disease, of death. You spend your days in contemplation, in art, in the exploration of the mathematics of reality. You look up at the sky, and you see a ceiling of 1 million stars. You know that out there, in the sparse spiral galaxies at the edge of the universe, there might be young, noisy civilizations just waking up. You watch them with a kind of nostalgic tenderness, remembering when you too were loud and fearful. You do not intervene. You let them learn. You let them grow. You are the watcher in the dark. The environment of IC 1101 would shape any life that evolved there in profound ways. We discussed the perpetual twilight of the core. On such a world, there would be no sleep cycle as we know it. Biology would not be tuned to the rhythm of day and night. Creatures might have evolved to be awake continuously, or to rest in short bursts. The concept of time might be fluid, not broken into days and years. And the radiation, the X-rays from the intracluster gas, the ultraviolet from the occasional flare, would force life to be robust. Evolution would favor repair mechanisms, thick skins, protective shells. It would be a tough, resilient kind of life, born in the fire and tempered by the radiation. There is also the question of metallicity. The first stars in the universe had no heavy elements, no iron, no carbon, no oxygen. Planets could not form around them. But IC 1101 has been enriching itself for 13 billion years. The gas in its stars is rich with the ashes of previous generations. This means that rocky planets, Earth-like planets, should be common. The building blocks are there. The table is set. The sheer abundance of material in a galaxy this size suggests that nature has tried every possible chemical experiment. If there is a way to make life based on silicon instead of carbon, IC1101 has probably done it. If there is a way to make life that floats in the atmosphere of a gas giant, IC1101 has probably done it. It is a laboratory of infinite iterations. But let us step back from the aliens and look at ourselves. Why does the thought of life in IC1101 matter to us? Why do we care if there are microbes on a rock 1 billion light years away? I think it is because we are looking for context. We are looking for family. When we look at the stars, we feel a sense of vertigo, a sense of being small and lost. Finding life elsewhere would tell us that we belong. It would tell us that the universe is not just a machine for making black holes, but a garden for growing minds. It would validate our own existence. It would mean that consciousness is not a fluke, but a fundamental property of the cosmos, something that arises inevitably whenever matter gets complex enough. This brings us to a beautiful concept called Pansychism, the idea that mind is everywhere. Maybe the universe isn't just a place containing life. Maybe it is alive in some sense. The complex feedback loops of the galaxy, the flow of energy, the self-regulation of the black hole, these look like the processes of biology. Perhaps IC1101 is, in its own way, a living entity. Not a biological one, but a systemic one. A creature of gravity and light, thinking thoughts that take 1 million years to formulate. We are like the bacteria living in its gut, unaware of the greater being we are part of. And even if we are alone, even if IC1101 is truly empty of life, that too is a profound truth. It would mean that we are the custodians of meaning for the entire universe. It would mean that our eyes are the only eyes seeing the glory. It would mean that our thoughts are the only thoughts breaking the silence. In that case, we have a responsibility that is terrifying in its weight. We have to survive. We have to remember. We have to tell the story. Because if we die, the universe goes blind. The beauty of the giant galaxy would still exist, but there would be no one to appreciate it. And does beauty exist if there is no one to see it? So, tonight, as you drift towards sleep, let your imagination travel across the void. Populate the stars of IC1101 with your dreams. Imagine the cities of crystal built on planets of diamond. Imagine the songs sung by creatures with voices like cellos, vibrating in the dense atmosphere of a super-Earth. Imagine the libraries filled with the history of 1 billion years. Whether they are real or not, they are real in your mind, and your mind is part of the universe. Therefore, in a way, they exist. The silence of the night is not empty. It is pregnant with possibility. Every star is a question. Every galaxy is an invitation. And you, the dreamer, are the answer. You are the universe's way of exploring its own potential. The journey to IC1101 is not just a journey through space. It is a journey through the landscape of what is possible. And the landscape is vast. The landscape is beautiful. The landscape is waiting. The thought of those 100 trillion stars should not make you feel insignificant. It should make you feel connected. You are made of the same atoms as the aliens you imagine. You are powered by the same energy. You are swimming in the same sea of space-time. The distance is an illusion. The separation is a trick of the light. In the deep, underlying reality of the cosmos, we are all one. We are the stardust that learned to dream. Sleep now in the company of the infinite. Let the stars of the giant galaxy watch over you. Let the mystery of life wrap around you like a warm blanket. You are not alone. You have never been alone. The universe is holding you. One of the most profound powers of the human mind is the ability to look at a smudge of light and see a world. We are creatures who constantly seek to interpret the signals that the universe sends us, turning photons into meaning and silence into stories. But the story of how we came to understand the true nature of IC 1101 is not just a story of scientific deduction. It is a ghost story. It is a story about peering into the deep past, about reading messages sent across an abyss of time so vast that the sender and the receiver inhabit completely different epochs of reality. When we point our telescopes at the constellation Virgo and capture the faint glow of that giant elliptical galaxy, we are engaging in a form of time travel that is as real and as terrifying as anything in science fiction. We are not seeing the universe as it is. We are seeing it as it was. We are archaeologists of the sky, digging through layers of light to uncover the ancient history of creation. And to understand the magnitude of this achievement, we must go back to a night in the late 18th century, to a quiet garden in England, where a man with a homemade telescope first laid eyes on the monster. The year was 1790. The astronomer was William Herschel, a musician turned stargazer who possessed an insatiable curiosity and a talent for grinding mirrors. On the night of June 19th, Herschel was scanning the sky, systematically mapping the heavens, when his telescope swept across a patch of darkness in the constellation Virgo. In his eyepiece, he saw a faint, fuzzy blob of light. It was not a star, which would appear as a sharp point. It was a cloud, a nebula, a whisper of luminosity against the black velvet of the night. Herschel dutifully recorded its position and its appearance, cataloging it alongside thousands of other such objects. But here is the tragedy and the wonder of that moment. Herschel had no idea what he was looking at. To him, it was likely just a cloud of gas within our own Milky Way, a relatively nearby object of modest size. He could not know that the light hitting his retina had been traveling for over 1 billion years. He could not know that the blob was an island universe containing 100 trillion stars. He stood on the shore of a cosmic ocean, looking at a leviathan, and mistook it for a piece of driftwood. For over a century, IC 1101 remained just another entry in a catalog, a mystery waiting for a solution. It was not until the 20th century, when our understanding of the scale of the universe expanded, that we realized the true nature of these nebulae. We learned that they were not clouds of gas, but entire galaxies, separate from our own, separated by distances that shattered our imagination. And with this realization came the shock of the light travel time. We discovered that looking out into space is identical to looking back in time. Light travels at a finite speed, 670 million miles per hour. It is fast, but it is not instantaneous. For the moon, the delay is just over a second. For the sun, it is 8 minutes. But for IC 1101, the delay is 1.04 billion years. Let us pause and try to inhabit that number. 1 billion years. When the light that we see tonight first left the surface of the stars in IC 1101, the Earth was a fundamentally different planet. There were no humans, no dinosaurs, no trees, no flowers. The continents were unrecognizable, gathered in ancient configurations that have long since drifted apart. The highest form of life on our world was simple, single-celled organisms, perhaps the very first experiments in multicellular life, living in the primordial oceans. The land was barren rock. The atmosphere was unbreathable to us. While that light was streaming through the void, traversing the immense emptiness between the galaxies, the Earth was slowly evolving. Complex life emerged. The oceans filled with fish. The land turned green with the first forests. The amphibians crawled from the water. The reptiles rose to dominance. The dinosaurs reigned for 150 million years and then were wiped out by an asteroid. Mammals scurried in the undergrowth, grew larger, and eventually a line of primates began to walk upright. Stone tools were chipped, fire was tamed, languages were spoken, pyramids were built, wars were fought, telescopes were invented, and finally, after a billion-year journey, that ancient light poured down the tube of a telescope and hit a digital sensor, carrying with it the image of a galaxy that might have changed completely in the interim. This is the vertigo of the astronomer. We are never in the present. We are always trapped in the past. The IC1101 we study is a ghost. It is the galaxy as it existed a billion years ago. We have no way of knowing what it looks like right now. In the billion years since that light left, the galaxy has rotated. Stars have died. New black hole mergers might have occurred. The civilization we imagined earlier might have risen and fallen a dozen times. It is possible, though unlikely, that the galaxy has been destroyed or altered beyond recognition. But we will not know for another billion years. We are cut off from the cosmic now by the insurmountable barrier of the speed of light. We are forever looking at a photo album of the universe's childhood, never meeting the adult. But this limitation is also a gift. Because light takes time to travel, the universe has preserved its history for us. By looking at galaxies at different distances, some a million light years away, some a billion, some 10 billion, we can see the different stages of galactic evolution. We can see the universe growing up. IC1101 provides us with a snapshot of what a massive elliptical galaxy looks like at the 1 billion year mark of look-back time. It is a data point in the grand timeline. If light traveled instantly, we would see the universe only as it is today, and we would have no idea how it came to be. We would see the old man, but never the child. The delay of light gives us the narrative. It turns the sky into a history book, with the farthest pages telling the oldest stories. The technology that allows us to read this book is a testament to human ingenuity. For centuries, we were limited by our eyes, which can only gather a tiny amount of light. Then we built glass eyes, lenses, and mirrors that could gather more light and see fainter objects. But we were still trapped at the bottom of an ocean of air. The Earth's atmosphere is a turbulent, shifting fluid that distorts starlight, making stars twinkle and blurring the fine details of distant galaxies. It acts like a frosted glass shower door, obscuring the view. To truly see IC1101, we had to leave the planet. We had to launch our eyes into the vacuum. The Hubble Space Telescope, floating above the atmosphere, changed everything. It stared at the giant galaxy with unblinking clarity, revealing the smooth gradient of its starlight, the vastness of its halo, and the peculiar emptiness of its scoured core. It allowed us to measure the galaxy's size with precision, stripping away the atmospheric blur to reveal the monster in all its glory. And we did not just take pictures, we dissected the light. Using a technique called spectroscopy, astronomers split the light from IC1101 into a rainbow of colors. This spectrum is like a DNA fingerprint. It tells us what the stars are made of. By analyzing the dark lines in the spectrum, we can identify the presence of hydrogen, helium, carbon, iron, and calcium. We can measure the temperature of the stars. We can even measure how fast they are moving. It was spectroscopy that revealed the galaxy is moving away from us, carried by the expansion of the universe. And it was spectroscopy that allowed us to calculate the distance of 1 billion light years through the measurement of redshift. Imagine the audacity of this. We take a few photons of light, ancient and weary from their long journey, and we force them to give up their secrets. We reconstruct the chemistry and physics of an object we will never touch, simply by studying the quality of its light. This brings us to a humbling realization about the universality of physics. The atoms in IC 1101 are the same as the atoms in your body. The iron in the spectrum of a distant star is identical to the iron in your blood. The laws of gravity that hold that galaxy together are the same laws that keep your feet on the ground. The universe is made of the same stuff everywhere. There is no exotic matter in the distance that follows different rules. This continuity is what makes astronomy possible. If the laws of physics changed from place to place, we would be lost. But they do not. We can understand the furnace of a star 1 billion light years away because we understand the nuclear fusion in our own sun. We are at home in the universe because the universe is consistent. But knowing how we measure it does not diminish the sheer improbability that we can measure it. Consider what we are. We are biological organisms, evolved to survive on the African savanna. Our brains are built to track prey, to navigate social hierarchies, to find water, and to avoid predators. We are built for the scale of meters and seconds. Nothing in our evolution prepared us to comprehend a number like 100 trillion, or a distance like 6 million light years, or a time span like 1 billion years. And yet, somehow, this ape brain has repurposed itself. We have taken the neural architecture designed for survival and turned it toward the cosmos. We have developed mathematics, a language that allows us to model realities we cannot visualize. We have built machines that extend our senses across the electromagnetic spectrum. We have broken the chains of our biological limitations. There is a famous image known as the Hubble Deep Field. Astronomers pointed the telescope at a tiny, empty patch of sky, a patch the size of a grain of sand held at arm's length, and opened the shutter for hundreds of hours. They expected to see nothing. Instead, the image revealed thousands of galaxies, spirals and ellipticals, gems of light scattered in the dark. It showed us that no matter where you look, no matter how small the window, the universe is full. IC 1101 is just one of those gems, one of 2 trillion galaxies in the observable universe. But the fact that we know it exists, the fact that we have singled it out and named it, is a triumph of consciousness. In a universe of mindless matter, of hydrogen gas, dark matter, and fusion reactions, we are the part of the universe that has woken up. We are the universe looking at itself. This act of looking is not passive. It is an act of connection. When you learned about IC 1101, you are holding the largest object in the universe inside your mind. The neural patterns in your brain are encoding the concept of a galaxy that is 6 million light years wide. In that moment, the microscopic and the macroscopic touch. The vastness of the cosmos is reflected in the complexity of the human mind. We are the mirror in which the universe sees its own face. Without us, or beings like us, IC 1101 would still exist, but it would be unobserved. It would be a tree falling in a forest with no one to hear. Our knowledge gives the universe a new dimension, the dimension of meaning. The distance to IC 1101 also serves as a calibration for our own place in history. We often feel that our time is the most important time, that our civilization is the pinnacle of existence. But looking at that billion-year-old light reminds us that we are latecomers. The universe has been busy for a long time before we arrived. Great empires of stars have risen and fallen while Earth was still a ball of molten rock. The drama of the cosmos does not revolve around us. We have walked onto the stage in the third act, just in time to catch a glimpse of the grandeur before the lights eventually dim. This is not a reason for despair. It is a reason for gratitude. We made it. We are here. We are conscious in the golden age of astronomy, the time when we can see the galaxies before the expansion carries them away. As we stand in the garden with William Herschel, looking over his shoulder at that fuzzy blob, we can see the trajectory of human curiosity. He saw a mystery. We see a galaxy. Who knows what our descendants will see? Perhaps they will find a way to cheat the light speed limit. Perhaps they will map the individual stars of the giant. Perhaps they will receive a signal from the silence. The journey of discovery is not over. We have only just scratched the surface of the dark. We have only just opened our eyes. And there is something deeply democratic about this knowledge. The light from IC 1101 is raining down on Earth right now. It is falling on your roof, on your garden, on the street outside your window. It is too faint to see with your eyes, but it is there. The photons are arriving. The message is being delivered. You do not need a billion-dollar telescope to be part of this. You just need to know that it is happening. You just need to look up toward Virgo and know that in that direction, past the stars of our own night, lies the giant. The connection is yours to claim. So, tonight, when you close your eyes, do not just think of the galaxy as a distant object. Think of the light. Think of the stream of photons that has been traveling since the dawn of life on Earth, rushing through the silence, carrying the image of 100 trillion stars just to reach us. Think of the patience of the universe, and think of the miracle that you are here to receive it. You are the destination of a billion-year journey. You are the witness the universe has been waiting for. We have traveled a great distance tonight, you and I. We have journeyed from the quiet safety of your bedroom to the edge of the observable universe, back to the fiery moment of the Big Bang, and forward to the silent, dark eons of the heat death. We have stood in the shadow of the colossal galaxy IC 1101, feeling the weight of its 100 trillion stars and the pull of its terrifying black hole. We have drifted through the hot, glowing fog of the Intracluster medium and felt the accelerating push of dark energy that is slowly tearing the cosmos apart. And now, as the journey draws to a close, as the eyelids grow heavy and the mind begins to surrender to the drift of sleep, we must return to the place where we started. We must return to the question that hangs over all of this like a ghost. What does it all mean? What is the terrifying truth about God and the universe that we promised to uncover? The answer is not found in a single equation or a single observation, but in the synthesis of everything we have seen. It is found in the realization that the boundary between you and the universe is an illusion. The terrifying truth is that you are not in the universe. You are the universe. And the God we seek is not a distant ruler, but the very fabric of reality itself, waking up to experience its own grandeur. To understand this, we must look one last time at the physics of your own existence. Consider the atoms in your right hand. There are roughly 7 octillion atoms in your body. Each one of them is billions of years old. As we have discussed, the hydrogen was born in the Big Bang. The carbon, nitrogen, and oxygen were forged in the cores of stars that died before the Earth was born. The iron in your blood was created in the supernova of a giant star. The gold in your jewelry was made in the collision of neutron stars. You are, quite literally, a museum of cosmic history. You are a collection of ancient debris that has been organized by the laws of physics into a thinking, feeling being. But this is not just a poetic metaphor. It is a physical fact. There is no point where the universe ends and you begin. The air you breathe is the atmosphere of the planet. The water you drink is the rain that fell from the sky. The energy that powers your brain is the sunlight captured by plants. You are a continuous process, a whirlpool in the river of matter and energy. This realization is terrifying because it destroys the ego. It destroys the idea that you're a separate, isolated entity fighting against a cold, indifferent world. It forces you to accept that you are an aperture through which the universe is looking at and exploring itself. As the astrophysicist Neil deGrasse Tyson said, we are part of this universe. We are in this universe, but perhaps more important than both of those facts is that the universe is in us. And as Carl Sagan famously whispered to the ages, we are a way for the cosmos to know itself. When you look at IC 1101, it is not a human looking at a galaxy. It is the galaxy looking at itself through the lens of a human eye. It is the hydrogen of the Big Bang, now complicated into a brain, looking back at the hydrogen of the Big Bang that remained simple gas. It is a loop. It is a mirror. And this brings us to the concept of God. For centuries, humanity has projected its own image onto the mystery of creation. We have imagined a God who looks like us, thinks like us, and cares about our tribal disputes. But the God revealed by science, the God of Einstein and Spinoza, is something far vaster, far more alien, and far more beautiful. It is the sum total of the laws of physics. It is the mathematical precision that sets the speed of light. It is the gravitational constant that holds the galaxies together. It is the logic that allows complexity to emerge from chaos. This God does not answer prayers to find lost keys, but it does answer the question of existence. It reveals itself in the terrifying order of the cosmos. It is the silence of the void and the fire of the stars. It is the logos, the rational principle that governs the universe. To study astronomy is to study the mind of this God. To solve an equation is to read a line of its scripture. When we look at the fine-tuning of the universe, the fact that the constants of nature are set just right to allow for life, we are seeing the signature of this order. We do not need to invoke a supernatural tinkerer to feel the awe of this. The order itself is the miracle. The fact that the universe is not chaos, that it follows rules, that it is comprehensible to our minds, is the source of a religious feeling that transcends dogma. Einstein called it a cosmic religious feeling. He wrote, "The most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. This feeling is what we have been cultivating tonight. It is the shiver you feel when you realize the size of IC 1101. It is the vertigo you feel when you contemplate the black hole. That shiver is the presence of the divine. It is the reaction of the finite mind touching the infinite. But there is a gentle side to this terrifying truth as well. If you are the universe, then you cannot die in the way you think you can. The laws of thermodynamics tell us that energy cannot be created or destroyed. It can only change form. The energy that makes up your consciousness, the electrical signals firing in your neurons, is part of the eternal energy of the cosmos. When your life ends, that energy does not vanish. It returns to the flow. The atoms of your body return to the earth, to the air, and eventually to the stars. You are a wave that rises from the ocean, crashes on the shore, and retreats back into the deep. The wave is gone, but the water remains. The form is temporary, but the substance is eternal. You have been here since the beginning, and you will be here until the end. You are an intrinsic part of the fabric of reality. You belong here. This perspective offers a profound peace. It relieves us of the burden of self-importance. We do not need to be the center of the universe, because we are the universe. We do not need to conquer the galaxy, because we are the galaxy. The vastness of IC1101 is not there to make us feel small. It is there to show us how big we really are. We are the consciousness of the giant. We are the dream of the red dwarf stars. We are the thoughts of the black holes. In the deep silence of your room, you can feel this connection. You can feel the gravity that pulls you down, the same gravity that holds the obel cluster together. You can feel the warmth of your blood, the same heat that radiates from the stars. You are a child of the cosmos, not just figuratively, but literally. And this brings us to the final paradox, the importance of the witness. In a universe that is largely dead matter, rocks, gas, dust, dark matter, consciousness is incredibly rare. As far as we know, we might be the only ones, or we might be one of a few. In either case, we are precious. Without us, the universe is just a script with no audience. It is a song with no listener. It is a painting with no viewer. We give the universe meaning. We give it a story. Our little lives, our loves, our struggles, our curiosity, these are the things that give the cosmos value. IC1101 is big, but it cannot love. It cannot wonder. It cannot cry. We can. We are the heart of the machine. The terrifying truth is that the universe needs us just as much as we need it. It needs us to acknowledge it. So, as we prepare to end this journey, let us make a pact. Let us promise to keep looking up. Let us promise to keep wondering. The world down here can be noisy, chaotic, and stressful. It can be easy to lose sight of the bigger picture, to get bogged down in the trivialities of the day. But the stars are always there. IC1101 is always there, hovering in the darkness of Virgo, a silent reminder of the scale of reality. Whenever you feel overwhelmed, whenever you feel lost, close your eyes and travel back to the giant. Remember the 100 trillion stars. Remember the billion-year journey of the light. Remember that you are made of stardust and that you are safe in the arms of the laws of physics. This journey we have taken is just one of many. The universe is infinite, and our exploration is just beginning. There are other galaxies to visit, other mysteries to solve, other terrors to confront and turn into beauty. We are a community of explorers, you and I. We are the sleepy scientists, the dreamers of the dark, the watchers of the night. And I am honored to be your guide. If this journey has brought you a sense of peace, if it has expanded your mind even a fraction of an inch, if it has helped you feel a little less alone in the vastness, then we have succeeded. I invite you to stay with us on this path. There are more stories to tell. There are more secrets hiding in the dark matter. There are more black holes to dive into. By being here, by listening, by wondering, You are keeping the flame of curiosity alive. You are doing the work of the universe. So, if you wish to continue this voyage, if you wish to be part of this community of stardust, simply let us know by your presence. Like the light from a distant star, your signal reaches us. Subscribe to the mystery. Join the expedition. We are traveling into the infinite, and there is plenty of room on the ship. But for now, the engines are powering down, the telescope is being capped, the data is being stored, the lights in the observatory are dimming. It is time to rest. It is time to let the rational mind sleep and let the dreaming mind take over. Let the images of the galaxies fade into the background of your dreams. Let the golden glow of IC 1101 wrap you in a blanket of light. Let the silence of the voids lull you into a deep, restorative slumber. You are safe. You are whole. You are home. The universe is not out there. It is in here, and it is beautiful. Good night, traveler.